history often gives the impression that the ancient world has already been explained. Dates have been assigned, civilizations have been categorized, and ruins has been mapped across the globe. But explanation is not the same as understanding. Many ancient sites still contain unanswered questions buried beneath accepted narratives: why certain cities were built in impossible locations, why some structures were abandoned at the height of their development, or why techniques once used on massive monuments seem to vanish from history entirely. In some cases, the surviving evidence creates more uncertainty than clarity. The stones remain, but the reasoning behind them does not. And as new discoveries continue to emerge from deserts, caves, jungles, and submerged ruins, the ancient world begins to look less like a completed timeline and more like a civilization-sized mystery still being uncovered. Carved directly into a volcanic cliff in the southern Georgia, overlooking the Kuria River Valley, Vardzia remains one of the strangest engineering mysteries of the medieval world. From the outside, it appears like a gigantic honeycomb cut into solid rock, but hidden inside the mountain once existed an entire underground city containing thousands of chambers, secret tunnels, water systems, chapels, wine cellars, storage halls, and defensive passages stretching across nearly 500 meters of cliff face. The greatest mystery is not simply its size, but the fact that this enormous complex was created during the 12th century, in an age when builders supposedly lacked advanced geological knowledge, seismic engineering, or precision excavation tools. Yet nearly 900 years later, large portions of Vardzia still remain standing, despite earthquakes, erosion, invasions, freezing winters, and the collapse of entire sections of the mountain itself. Many historians describe it as a monastery. Many engineers describe it as something far more difficult to explain. Although Vardzia was known locally for centuries, much of its hidden structure only became visible after a massive earthquake in the year 1283. The quake tore away huge sections of the mountain's outer face, exposing chambers and tunnels that had previously been concealed deep inside the cliff. What shocked later explorers was the scale of the complex. Archaeological surveys revealed that Vardzia originally contained more than 3,000 rooms distributed across approximately 13 levels. Some tunnels extended over 150 meters into the mountain, while certain chambers reached depths of nearly 50 meters from the cliff surface. Modern laser scans suggest that the visible ruins today may represent only a fraction of the original structure. One of the greatest unsolved mysteries surrounding Vardzia is the excavation itself. Unlike Petra in Jordan, where many structures were carved into relatively stable sandstone facades, Vardzia was excavated into volcanic tuff, a softer rock that is easier to cut but far more vulnerable to cracking and collapse under stress. In modern geology, removing too much material from volcanic tuff can destabilize entire cliff systems. Yet the builders of Vardzia somehow created thousands of interconnected voids without triggering catastrophic structural failure. Even more mysterious is the internal layout. Modern structural engineers studying the ruins noticed that many chambers appeared deliberately positioned along naturally stable rock layers. Certain corridors curved slightly instead of following straight lines, helping redistribute pressure throughout the mountain. Several stone pillars left inside the tunnels initially appeared decorative. However, geological analysis suggests they function more like load-bearing support columns similar to the pillar retention systems used in modern underground mining. No surviving blueprints exist. No written engineering manuals explain how medieval builders could understand internal rock stress at such a sophisticated level. Some researchers believe the builders learned through generations of empirical observation. Others argue the precision seems too consistent to be entirely accidental. The earthquake of 1283 should have destroyed Vardzia completely. Instead, something unexpected happened. While the outer face of the cliff collapsed dramatically, large sections of the inner complex survived. Stairways, hidden chambers, ventilation shafts, and underground halls remain structurally intact despite enormous seismic forces. This has led some modern engineers to propose that Vardzia's design unintentionally behaved like a primitive anti-seismic structure. Unlike freestanding buildings, which absorb seismic energy directly through walls and foundations, Vardzia existed inside the mountain itself. The surrounding rock mass may have dispersed part of the earthquake's energy before it reached the internal chambers. More surprisingly, laser mapping has revealed strange empty gaps between clusters of rooms. These spaces appear too deliberate to be random excavation leftovers. Some structural analysts believe they may have acted as primitive stress relief zones designed to reduce crack propagation during earthquakes. If true, Vardzia may represent one of the earliest examples of large-scale passive seismic engineering ever discovered. Another mystery involves survival. At its peak, historians estimate Vardzia may have sheltered several thousand people during invasions. Sustaining that population inside a mountain would have required enormous quantities of fresh water. Archaeologists discovered an intricate hydraulic network carved directly into the rock. Water channels transported spring water from higher elevations throughout the complex using carefully controlled gradients. This precision is difficult to explain. In modern hydraulic engineering, even slight slope miscalculations can cause water stagnation, flooding or erosion. Yet many Vardzia channels maintained stable flow over centuries. Some tunnels also contain mineral coatings resembling primitive waterproofing compounds. The exact composition of these materials remains poorly understood. Despite centuries of moisture exposure, portions of the channel still resist significant leakage. Several researchers have compared the hydraulic sophistication of Vardzia to certain Roman systems, despite Georgia being far outside the core engineering sphere of the Roman Empire. Ventilation may be one of the most underrated mysteries of Vardzia. A city hidden inside rock should have suffered from smoke accumulation, oxygen depletion, humidity buildup, and dangerous temperature fluctuations. Yet modern measurements show that many chambers maintain surprisingly stable internal temperatures throughout the year. Researchers discovered narrow shafts and concealed openings integrated into the cliff system. These passages appear positioned to create pressure differences that naturally circulate air through the complex. The principle resembles modern passive ventilation engineering. Warm air rises through upper shafts while cooler air enters from lower openings, generating continuous airflow without mechanical assistance. What makes the system remarkable is its concealment. Many ventilation openings are nearly invisible from outside the mountain, preserving the defensive secrecy of the complex. Some military historians believe this integration of survival engineering and camouflage was centuries ahead of its time. The most haunting mystery inside Vardzia may not be the tunnels or the engineering. It may be the paintings. Deep within the Church of the Dormition, ancient frescoes still cling to the stone walls after nearly 9 centuries. They survived earthquakes, smoke exposure, moisture, mineral deposits, freezing winters, and centuries of human activity inside the caves. Under normal conditions, medieval wall paintings in humid cave environments deteriorate rapidly. Pigments fade, plaster separates, organic binders decay. Yet many Vardzia frescoes remain astonishingly vivid. Among the most famous are the portraits believed to depict Queen Tamar and King Georgi III. The pigments retain remarkable depth despite their age. Scientific pigment analysis identified mineral compounds including lapis-derived blues, iron oxides, copper-based greens, and rare imported materials not commonly available in the region during that period. This raises major questions about medieval Georgian trade networks and artistic technology. But the greater mystery lies in preservation. Modern conservators studying the frescoes found that certain pigment layers bonded unusually well to the cave walls. Some areas show adhesion strength far beyond what would normally be expected from medieval limeplaster techniques. Microclimate studies inside the church suggest that the cave's stable humidity and temperature may have unintentionally created ideal preservation conditions. However, this explanation remains incomplete because nearby cave paintings of similar age in other regions deteriorated far more severely despite comparable environments. Some researchers suspect the plaster mixture itself may have contained unique mineral additives enhancing durability. Others believe the volcanic chemistry of the surrounding rock interacted with the pigments in unexpected ways over centuries, effectively sealing parts of the artwork. No consensus exists. Even today, conservators struggle to fully explain why the colours survived so well, while entire civilizations vanished around them. The paintings appear less like fragile medieval art and more like messages trapped inside stone. Do you think Vardzia was simply an extraordinary medieval achievement, or evidence of engineering knowledge far ahead of its time? Share your thoughts in the comments below. At the junction of the Vardar and Kurnar rivers in modern-day Stobi lies the remains of a city that continues to disturb archaeologists and engineers alike. At first glance, Stobi appears to be another ruined Roman settlement, but buried beneath its theatres, temples, streets and churches are signs of something far stranger: hydraulic systems with near-modern precision, earthquake-resistant foundations centuries ahead of their time, and mosaics so mathematically perfect that some researchers question how ancient craftsmen achieved them without advanced measuring technology. The greatest mystery of all may not be how Stobi was built, but how so much of its engineering knowledge vanished from history after the city collapsed. The ruins of Stobi were known locally for centuries, but systematic archaeological excavations only began in the late 19th and early 20th centuries during the Ottoman and later Yugoslav periods. Early explorers uncovered fragments of marble columns, mosaic floors, and inscriptions that revealed Stobi had once been one of the most important cities in the Roman province of Macedonia Salutaris. As excavations expanded throughout the 20th century, archaeologists discovered an unexpectedly advanced urban centre covering more than 20 hectares. Beneath layers of destruction caused by invasions and earthquakes, entire engineering systems remained preserved. Underground drainage tunnels, complex water channels, thermal bath structures, and enormous mosaic halls. Each excavation season seemed to reveal another contradiction to the assumption that provincial Roman cities were technologically simple compared to Rome itself. Among all the mysteries surrounding Stobi, nothing has generated more debate than its mosaics. Some of the floors discovered inside basilicas and elite residences contain geometric patterns and symbolic imagery assembled with astonishing precision over enormous surfaces. Modern laser scans conducted on several surviving mosaics revealed alignment deviations measuring only a few millimeters across sections spanning multiple meters. That level of consistency becomes difficult to explain when considering the limitations of ancient tools. Roman artisans supposedly relied on ropes, chalk lines, wooden rulers, and visual estimation. Yet some Stobi mosaics demonstrate symmetry comparable to machine-guided layouts. The mystery deepens further when examining the tesserae themselves, the tiny coloured stones and glass pieces forming the images. Researchers identified carefully selected minerals capable of retaining pigment intensity for nearly 2,000 years. Red colours likely came from iron oxides heated under controlled conditions. Blues may have involved copper compounds or imported minerals. Several yellow pigments display unusual crystalline stability, surviving despite centuries of humidity and temperature variation. Some mosaics appear to use layered optical techniques. Darker tesserae were placed beneath lighter stones at specific intervals, producing depth and shadow effects visible only from certain viewing angles. Similar visual manipulation techniques are associated with much later Byzantine and Renaissance art traditions. One particularly famous mosaic depicting peacocks and flowing vegetation demonstrates almost mathematical repetition in its geometric border patterns. Digital reconstructions showed repeating proportional ratios close to 1.6, remarkably near what modern mathematics recognizes as the golden ratio. Whether this was intentional or accidental remains fiercely debated. Comparisons with mosaics from Pompeii and Ravenna reveal that Stobi's craftsmanship rivals some of the finest known works in the Roman world, despite being located far from the empire's primary artistic centres. Even more puzzling is the durability of the floors. Many sections remain structurally intact despite repeated earthquakes. Engineers studying the mosaic foundations discovered layered construction methods involving compacted gravel, lime mortar, ceramic fragments, and flexible sublayers capable of absorbing stress. This resembles primitive seismic engineering, a concept not formally understood until modern structural science. The mosaics of Stobi are no longer viewed merely as decoration. Increasingly, they are seen as evidence of highly sophisticated material science and geometric planning that ancient, historical records barely mention. Another mystery lies underground. Excavations uncovered an extensive network of drainage and water management systems running beneath the city. Stone-lined channels carried water across long distances, with gradients so subtle that modern survey equipment detected elevation changes of only a few centimeters over several meters. That level of hydraulic precision was critical. Too steep and erosion would destroy the channels, too shallow and water stagnation would occur. Yet Stobi's system maintained stable flow for centuries. Some sections contain waterproof mortar compositions similar to Roman pozzolanic concrete. Laboratory analysis found mixtures of lime, volcanic ash, and crushed ceramics capable of resisting moisture penetration far more effectively than ordinary mortar. The exact sourcing of some ingredients remains unclear, because volcanic materials are not naturally abundant near the city. Researchers comparing Stobi's drainage infrastructure to systems found in Ephesus noted surprisingly similar engineering principles, despite the geographic distance between the cities. Even more impressive is evidence suggesting self-cleaning water flow. Certain tunnel sections narrow strategically before widening again, increasing water pressure temporarily and flushing accumulated sediment forward. This principle resembles modern hydraulic flushing systems. How provincial engineers acquired and maintained such expertise remains one of the city's greatest unanswered questions. The Balkan region has experienced destructive seismic activity for thousands of years. Historical records suggest Stobi itself suffered multiple earthquakes before its final decline in the 6th century. Yet many major structures survived far longer than expected. Excavations revealed unusually thick foundations beneath important buildings. In several locations, layers of crushed stone and flexible debris were intentionally inserted below walls. Modern engineers recognize this principle as a primitive form of vibration dampening. Certain walls also alternated between rigid stone blocks and softer mortar-rich layers, distributing stress instead of concentrating it. Similar concepts appear in some earthquake-resistant Japanese and Incan structures, separated by vast distances and centuries of development. One study comparing collapse patterns in Stobi and nearby Roman settlements found that several Stobi buildings resisted lateral structural failure significantly better than neighbouring sites constructed using more conventional techniques. This raises a disturbing possibility. Ancient builders in Stobi may have empirically understood seismic behaviour through centuries of observation and experimentation, even without formal scientific theory. The Roman theatre of Stobi presents another engineering puzzle. Despite heavy damage, acoustic modelling demonstrated that sound projected from the stage could travel clearly to upper seating areas without amplification. The arrangement of seating angles, reflective stone surfaces, and curved architectural geometry appears intentionally optimized for voice projection. Modern simulations indicate that certain frequencies were naturally reinforced, while echoes were minimized. Some researchers argue that Roman architects developed practical acoustic knowledge through experimentation rather than theoretical mathematics. Others believe the precision visible in Stobi suggests a far deeper understanding of wave behaviour than historians usually attribute to ancient provincial engineers. The theatre may not simply represent entertainment architecture, it may represent lost acoustic science. By the 6th century, invasions, economic collapse, and natural disasters devastated Stobi. The city gradually disappeared beneath soil and debris. But perhaps the greatest mystery is what disappeared with it. Could the engineering techniques found in Stobi really be just ordinary Roman technology? Or are we looking at traces of an ancient level of knowledge far more advanced than history has ever admitted? Leave your thoughts in the comments below. Far from the massive stone empires that usually dominate ancient history, Thep Historical Park lies hidden within the fertile basin of central Thailand, a lost city whose level of engineering has become increasingly difficult to explain. From the ground, Thep appears quiet and almost ordinary, but from above, the ruins reveal something unsettling: geometric reservoirs, carefully aligned city walls, and traces of a massive urban system that once controlled water, trade, metallurgy, and possibly even astronomical planning across a harsh seasonal landscape. What makes Thep so mysterious is not simply its age, but the fact that many of its technologies appear far more advanced than historians once believed possible for inland Southeast Asia during the first millennium. Even more disturbing, the civilization that built it almost completely vanished, leaving behind no detailed written explanation of how such a sophisticated city was created. The modern rediscovery of Thep began in the early 20th century when Prince Damrong Rajanubhab surveyed the region and recognized unusual earthworks hidden beneath vegetation. Later excavations throughout the 1960s and 70s uncovered massive moats, religious monuments, hydraulic systems, and refined metal artifacts spread across an urban area covering nearly 4.7 square kilometers. Satellite imaging later revealed that the city was far larger and more geometrically organized than archaeologists first imagined. In 2023, UNESCO officially recognized Thep as a World Heritage Site, but the designation only intensified debates surrounding how advanced this forgotten center truly was. One of the greatest mysteries surrounding Thep is the scale of the city itself. Unlike Angkor in Cambodia or ancient capitals situated beside enormous rivers, Thep stood in an inland basin with unpredictable seasonal rainfall and long dry periods. Yet archaeological surveys identified more than 70 artificial reservoirs and interconnected canals surrounding the city. Many of these reservoirs were engineered with gradients precise enough to regulate water flow naturally, without rapidly eroding the embankments. Modern hydrologists studying the terrain discovered that some reservoirs were positioned to capture monsoon overflow, while others redistributed water gradually during dry months. The system functioned almost like a giant hydraulic battery storing seasonal energy for later survival. What makes this even harder to explain is the material used to build much of the infrastructure. The people of Thep primarily relied on compacted earth, laterite blocks, and organic reinforcement rather than massive stone architecture. In tropical climates with intense monsoon cycles, such structures normally collapse within centuries. Yet parts of Thep's hydraulic network survived for over 1,000 years. Engineers analysing soil density around the embankments found evidence of layered compaction techniques that distributed pressure surprisingly efficiently. Some sections even show traces of what appears to be deliberate sediment filtering, reducing long-term erosion. Comparable water management systems would later appear at Angkor, but Thep predates many of those hydraulic expansions by centuries. The city's layout presents another unsettling puzzle. Aerial imaging shows that several major roads and ceremonial structures align unusually close to cardinal directions. Certain pathways appear oriented towards solar events, particularly sunrise positions during seasonal transitions. Similar astronomical planning has been documented at sites like Teotihuacan and Mohenjo-Daro, where urban geometry may have reflected cosmological beliefs. But unlike those civilizations, Thep left behind almost no surviving scientific texts explaining how such alignments were calculated. Archaeologists suspect that priest engineers may have used solar shadows, star positions, and seasonal observations to map the city with remarkable precision. Yet the scale of coordination required suggests knowledge far beyond simple trial and error. The deeper excavations went, the stranger Thep became. Researchers uncovered evidence that the city participated in enormous international trade networks stretching across Asia. Beads discovered at the site contained chemical compositions linked to India, Sri Lanka, and possibly even regions connected to Persian Gulf trade. Some glass artifacts were manufactured using mineral recipes not naturally available in central Thailand. This means raw materials, technological knowledge, or finished products travel thousands of kilometers into what was once assumed to be a relatively isolated inland kingdom. But perhaps the most shocking discoveries involve metallurgy and precision craftsmanship. Archaeologists at Thep uncovered bronze statues, gold ornaments, iron tools, and highly refined decorative objects whose manufacturing quality rivals far larger ancient civilizations. Metallurgical analysis revealed that some bronze artifacts contained unusually controlled alloy ratios, requiring careful regulation of temperature and oxygen during smelting. Achieving such consistency in ancient furnaces is extremely difficult. Even minor fluctuations in airflow can ruin an alloy batch by introducing brittleness or impurities. Researchers examining microscopic crystal structures inside several bronze fragments found evidence of advanced thermal management during casting. The metal appears to have cooled at controlled rates, reducing internal fractures and increasing durability. Some experts believe the craftsmen may have understood practical forms of annealing, reheating and cooling metal intentionally to improve strength. Centuries before, such techniques became widely associated with later industrial traditions. Iron production at Thep raises even more questions. Excavations uncovered slag deposits suggesting large-scale smelting operations, capable of producing significant quantities of usable iron. In tropical Southeast Asia, achieving the sustained furnace temperatures needed for efficient iron extraction is extremely challenging because humidity disrupts combustion efficiency. Yet the evidence indicates that Thep's metallurgists maintain temperatures likely exceeding 1,100 degrees Celsius in certain operations. Several archaeologists compared the sophistication of Thep's metallurgy to contemporary Indian Gupta workshops, particularly in terms of alloy purity and decorative finishing. This comparison is startling because the Gupta Empire represented one of the most scientifically advanced civilizations of its era. If Thep truly achieved comparable metallurgical precision, then Southeast Asia during the first millennium may have possessed technological capabilities historians dramatically underestimated. Gold craftsmanship discovered at the site is equally difficult to dismiss. Tiny ornamental details on jewelry pieces indicate the use of extremely fine tools and highly controlled shaping methods. Some gold sheets were hammered so thin that modern researchers initially believed they belonged to much later periods. Decorative patterns also suggest repeated heating cycles, designed to preserve flexibility while preventing cracking. These are not crude tribal artifacts. They are the products of highly specialized artisans working within a sophisticated technological culture. Another mystery lies in the cultural fusion visible throughout the city. Hindu iconography, Buddhist symbolism, Mon artistic influence, Khmer architectural elements, and Indian Gupta styling all appear within the same urban environment. Historians still debate how such a relatively remote inland city became a convergence point for so many advanced traditions simultaneously. Some researchers now believe Thep may have functioned as a regional knowledge exchange centre where merchants, priests, engineers, and craftsmen transmitted ideas across ancient Asia. Then, almost inexplicably, the city declined. There is no definitive evidence of catastrophic invasion or total destruction. Instead, the decline appears gradual and strangely silent. Some theories blame climate instability that may have disrupted the hydraulic system. Others point toward shifting trade routes that bypass the city. Pollen analysis from surrounding sediments suggests environmental stress increased during the later occupation phases, possibly reducing agricultural reliability. Yet none of these explanations fully account for why such an advanced urban centre vanished so completely from historical memory. Do you think Thep was simply a forgotten ancient city, or the remains of an advanced civilization whose knowledge was far beyond what modern history once believed? Possible? Leave your thoughts in the comments below. In the middle of Chile's Atacama Desert, one of the driest places on Earth, hundreds of enormous figures stretch across barren, mountain slopes where almost nothing survives. Chug Chug geoglyphs remains one of South America's least understood ancient mysteries. Unlike the famous Nazca lines, many of these geoglyphs were not built on flat plains, but on steep rocky hillsides where accurate large-scale construction should have been nearly impossible. Some figures exceed 50 meters in length, maintain geometric consistency across unstable terrain, and can only be fully recognized from extreme distances or high elevations. The greatest mystery is not simply why they were created, but how ancient people achieved this level of spatial precision. Without aerial observation, modern surveying tools, advanced engineering technology, the Chug Chug geoglyphs are located in the Tarapacá region of northern Chile, deep within the Atacama Desert. Archaeologists believe most of them were created between approximately 600 and 1400 AD by pre-Columbian Andean cultures connected to ancient caravan trade routes. The site remained largely unknown to the outside world for centuries because of its remote location and the brutal desert environment. Systematic archaeological surveys only expanded during the 20th century, especially after aerial photography and satellite imaging revealed the enormous scale of the geoglyph networks spread across the desert hills. Researchers eventually identified thousands of geoglyphs throughout the Atacama region, making it one of the largest concentrations of ancient landscape art on Earth. But what separates Chug Chug from many other geoglyph sites is the engineering problem hidden behind the artwork itself. The first and perhaps greatest mystery is the geometric accuracy achieved on terrain that should have made precision construction almost impossible. The Nazca lines of Peru were primarily drawn on relatively flat desert plains, allowing large shapes to be measured more easily using ropes, stakes, and ground-level observation. Chug Chug is fundamentally different. Many figures were constructed directly onto steep mountain slopes covered with loose volcanic rock and unstable sediment. From ground level, the creators themselves would have struggled to see the full proportions of what they were building. Yet many of the figures maintain remarkably stable symmetry. Human figures, llamas, geometric diamonds, parallel lines, and step motifs preserve balanced proportions despite being stretched across uneven surfaces. Modern topographic studies show that some alignments remain surprisingly accurate over long distances, even when adjusted for slope distortion. In several cases, straight-line formations continue across broken terrain, with deviations so small that modern researchers compare them to intentional surveying rather than simple artistic improvisation. This creates a serious technological question. How did ancient builders visualize massive designs they could never fully observe from their own position? Some archaeologists believe the creators used primitive grid system made from ropes and wooden stakes. Others propose that they relied on elevated observation points across opposing hillsides. But even these theories leave major gaps. The desert environment constantly shifts loose rock downhill through erosion and thermal stress. Daytime surface temperatures in parts of the Atacama can exceed 50 degrees Celsius, while nighttime temperatures drop dramatically, causing repeated expansion and contraction of rock surfaces. Maintaining straight lines and proportional geometry under such conditions would require continuous correction and sophisticated planning. The construction methods themselves reveal another layer of mystery. The Chug Chug geoglyphs were not created using a single technique. Researchers identified at least 3 different engineering approaches. Some figures were made by removing the dark oxidized surface stones to expose lighter sediment beneath, similar to the Nazca method. Others were built by carefully arranging dark stones into shapes. In some cases, both techniques were combined within a single geoglyph to maximize visual contrast. This suggests that the builders possessed a surprisingly advanced understanding of visual perception across long distances. They knew how sunlight, shadow, slope, angle and color contrast interacted under desert conditions. Several geoglyphs remain visible from hundreds of meters away despite centuries of erosion. Some stone arrangements appear intentionally selected for similar size and coloration, implying organized labor and pre-planned material selection rather than random placement. The survival of these structures may itself represent an ancient engineering achievement. The Atacama Desert receives less than 15 millimeters of rainfall annually in certain regions, making it one of the driest environments on Earth. While the dryness helps preserve archaeological remains, the environment is also intensely destructive in other ways. Strong winds, thermal expansion, salt crystallization, and unstable sediment gradually break down exposed surfaces over time. Yet many Chug Chug geoglyphs remain sharply recognizable after nearly 1,000 years. Researchers still debate whether the builders intentionally selected geologically stable hillsides to maximize preservation. Some formations appear positioned where natural drainage and wind patterns minimize erosion. If true, this would suggest an impressive empirical understanding of desert geology developed long before formal scientific methods existed. Another mystery involves the connection between the geoglyphs and ancient trade systems. Many figures depict llama caravans carrying goods across the desert. Archaeological evidence shows that caravan trade routes linked Pacific coastal communities with highland Andean settlements hundreds of kilometers away. Llamas transported obsidian, copper, textiles, salt, shells, and food across extremely dangerous terrain. Some experts believe the geoglyphs acted as enormous navigational markers guiding caravans through the desert. This theory gains support from the fact that many geoglyph clusters appear near ancient pathways and water access routes. Certain symbols repeat consistently across different regions, suggesting a standardized visual language understood by traders moving through the Andes. But this explanation creates another problem. If the geoglyphs only functioned as route markers, why make many of them so massive and visually complex that they could only be fully appreciated from high elevations? Simple directional markers would have required far less labor and precision. Instead, many figures contain elaborate symbolic details invisible from nearby ground positions. This has led some researchers to propose ceremonial or religious purposes connected to sky deities, mountain worship, or astronomical observation. Several studies suggest possible alignments between certain geoglyph orientations and solar positions during seasonal changes. Ancient Andean societies often integrated astronomy into agriculture, religion, and navigation. However, evidence for direct astronomical design at Chug Chug remains controversial because the alignments are difficult to prove conclusively. The sheer scale of labour involved presents another unresolved question. Thousands of geoglyphs exist throughout the Tarapacá region, spread across immense distances. Constructing even a single large hillside figure would have required coordinated teams moving and arranging large quantities of stone under extreme desert heat. Maintaining stylistic consistency across centuries suggests the existence of stable systems for transferring technical knowledge between generations. Yet archaeologists have never discovered formal workshops, engineering tools, or written instructions explaining how these methods were taught. What do you think the Chug Chug geoglyphs were truly built for? Navigation, astronomy, religion, or something we still completely misunderstand? Let us know your thoughts in the comments section below. Cacaxtla sits on a quiet hill in central Mexico, yet hidden inside its ancient walls are colours that should not still exist. More than 1,000 years after the city was abandoned, vivid blues, reds, blacks, and yellows still cling to its murals with impossible intensity. The greatest mystery is not the city itself, but the technology behind a pigment known as Maya blue, a material so chemically stable that even modern scientists struggle to fully understand how ancient civilizations created it without modern laboratories, controlled furnaces, or industrial chemistry. Cacaxtla remained buried for centuries beneath earth and vegetation in the modern Mexican state of Tlaxcala. In 1975, local farmers accidentally uncovered fragments of painted walls while working the land near the archaeological zone. Excavations led by Mexican archaeologists soon revealed one of the most extraordinary mural complexes ever discovered in Mesoamerica. Unlike many ancient paintings that survive only as faded traces, the murals of Cacaxtla appeared shockingly vibrant. Researchers immediately realized this site was different. The preservation quality rivaled some Egyptian tomb paintings despite existing in a far wetter and harsher environment. Further excavations uncovered ceremonial platforms, elevated plazas, drainage systems, and elite compounds connected to the Olmeca Xicallanca culture, a group believed to have risen after the collapse of Teotihuacan around the 7th century. Yet the artistic complexity discovered at Cacaxtla seemed far beyond what historians expected from a relatively small regional city. The most famous structure at Cacaxtla is the Battle Mural, a massive painted scene stretching more than 20 meters across temple walls. It depicts warriors wearing jaguar costumes, bird helmets, and marine imagery in astonishing detail. Nearby murals inside the Temple of Venus show celestial symbolism connected to astronomy and ritual power. What shocked researchers most was the survival of the colours themselves. Normally, pigments in tropical or semi-humid climates decay rapidly because moisture breaks down organic compounds. Across many Mesoamerican sites, murals have faded into faint shadows after only a few centuries of exposure. Yet at Cacaxtla, the pigments remained extraordinarily stable after more than 1,000 years. Scientific analysis revealed the use of iron oxides, carbon blacks, calcium compounds, and rare clay minerals. Some pigments penetrated deeply into multiple lime plaster layers, almost chemically bonding with the wall itself. This process resembles aspects of modern fresco techniques used during the European Renaissance centuries later. Researchers compared the durability of Cacaxtla's murals to Roman frescoes preserved at Pompeii. But there is a critical difference. Pompeii's paintings survived largely because volcanic ash sealed them in a dry environment after the eruption of Mount Vesuvius in 79 CE. Cacaxtla survived exposed to seasonal humidity, rain, temperature fluctuations, and biological decay. That difference makes its preservation even more difficult to explain. The greatest technological mystery at Cacaxtla centers around the famous pigment known today as Maya blue. Some blue sections of the murals contain chemical characteristics linked to this legendary material, one of the most durable pigments ever produced in the ancient world. Modern scientists spent decades trying to understand why Maya blue behaves unlike ordinary paint. Under laboratory testing, the pigment resists acid damage, humidity, chemical corrosion, and biological decomposition. Even nitric acid struggles to destroy it completely. Many modern synthetic pigments degrade faster. The secret lies in an extraordinary molecular structure created by combining indigo dye with a rare clay mineral called palygorskites. On paper, the ingredients sound simple. In reality, producing the pigment requires precise heat control. Studies suggest temperatures between approximately 150 and 200 degrees Celsius were necessary for the chemical bond to stabilize correctly. That creates a massive historical problem. Ancient Mesoamerican civilizations had no thermometers, industrial kilns, or modern chemistry equipment. If the temperature was too low, the molecular channels inside the clay would not absorb the indigo properly. If the temperature became too high, the organic dye would burn away completely. The process required an incredibly narrow thermal balance. Even more mysterious is the consistency. The pigment found across different Mesoamerican regions maintained remarkably similar chemical stability over centuries. That suggests ancient artisans possessed a standardized technical process sophisticated enough to reproduce the material repeatedly with minimal error. Some chemists compared Maya blue to nanocomposite materials because the organic dye molecules become trapped inside microscopic channels within the clay structure. In simple terms, the color becomes physically locked into the mineral itself. This is partly why the pigment survives moisture and oxidation so effectively. For decades, laboratories struggled to recreate authentic Maya blue with the same long-term durability. Some reproductions initially looked identical, but later degraded faster than archaeological samples. This led researchers to suspect that ancient artisans may have used additional steps or organic adhesives still not fully identified. At Cacaxtla, the presence of such advanced pigment technology raises uncomfortable questions for conventional assumptions about ancient engineering. How did artisans discover this process without modern chemistry? Was it accidental experimentation repeated over generations? Or did specialized knowledge networks exist across Mesoamerica, transmitting material science techniques with astonishing precision? The mystery becomes even deeper when considering scale. Cacaxtla was not a gigantic empire like Rome or Han China, yet its artisans achieved material stability rivaling some modern engineered pigments. The mysteries of Cacaxtla extend far beyond paint. The city itself demonstrates surprising engineering sophistication for a regional center. The site sits on elevated terrain exposed to seasonal rainstorms. Normally, plaster structures in such conditions erode rapidly, yet many of Cacaxtla's foundations and wall layers remained stable for centuries. Archaeologists discovered carefully designed drainage channels, directing rainwater away from ceremonial structures. Elevated platforms reduced soil saturation during storms, while lime-based plaster coatings helped seal surfaces from moisture infiltration. Microscopic analysis of the plaster revealed multiple finely polished layers. Some surfaces appear burnished to reduce porosity, similar to waterproof finishing techniques used in later civilizations. Achieving such smoothness required precise timing during plaster curing. If polished too early, the material would deform. Too late, and it would crack. The engineering becomes even more impressive considering the absence of metal construction tools comparable to those of the classical Mediterranean world. Another unresolved mystery is the strange mixture of artistic traditions found at Cacaxtla. The murals contain clear Maya influences from southern tropical regions hundreds of kilometers away, including bird-serpent imagery, jaguar symbolism, and complex celestial iconography. Yet Cacaxtla lies deep within central Mexico. Historians once believed cultures in these regions remained relatively isolated after the fall of Teotihuacan, but the murals suggest extensive long-distance interaction. Marine imagery appears despite the city being far inland. Exotic feathers, obsidian trade routes, and tropical symbolism imply networks of exchange spanning enormous distances. Some researchers believe Cacaxtla may have become a knowledge hub during the political vacuum left by Teotihuacan's collapse. Instead of military dominance, the city may have gained power through control of trade, ritual knowledge, and elite artistic production. Several murals and architectural alignments at Cacaxtla appear connected to the planet Venus, one of the most sacred celestial bodies in Mesoamerican religion. Venus was associated with warfare, rulership, sacrifice, and cosmic cycles. Tracking Venus accurately is extremely difficult because its visibility patterns shift through complex cycles lasting approximately 584 days. Ancient astronomers needed decades of systematic observation to predict its appearances with precision. Some mural compositions may encode celestial timing systems linked to Venus cycles. If true, this would place Cacaxtla among the advanced astronomical centers of ancient Mesoamerica despite its relatively modest physical size. Do you think the secrets of Cacaxtla were truly lost forever? Or could traces of that ancient knowledge still be waiting to be discovered? Share your thoughts in the comments below. In the dry plains surrounding the Vaigai River in southern India, beneath layers of ordinary farmland near Keezhadi, archaeologists uncovered something that should not have existed according to mainstream history. Hidden under the soil was evidence of an advanced urban settlement more than 2,000 years old, complete with organized streets, industrial production zones, sophisticated water systems, mass-produced fired bricks, and one of the earliest large concentrations of Tamil writing ever discovered. But the greatest mystery was not simply that Keezhadi existed. It was that its technological sophistication appeared centuries ahead of what historians once believed possible for southern India. The discovery of Keezhadi began after archaeologists started surveying the Vaigai River Valley, searching for traces of early Tamil civilization mentioned in ancient Sangam literature. Excavations led by the Archaeological Survey of India revealed brick structures, ring wells, drainage systems, pottery with Tamil Brahmi inscriptions, iron tools, beads, and industrial debris buried beneath the surface. Radiocarbon dating from charcoal samples pushed some layers back to around the 6th century BC, placing Keezhadi among the earliest urbanized settlements in southern India. The deeper researchers dug, the more the site resembled a carefully planned city rather than a scattered farming village. One of the first mysteries surrounding Keezhadi was its urban planning. Ancient settlements across much of early South India were traditionally believed to have been largely rural and decentralized. Keezhadi contradicted that image completely. Excavations revealed aligned brick structures, organized habitation zones, drainage channels, waste disposal systems, and evidence of separated industrial areas. The layout suggested not random growth, but deliberate planning. Some archaeologists even noticed similarities between the proportional measurements of Keezhadi bricks and the standardized brick ratios used in the ancient Indus Valley civilization over 1,000 years earlier. That comparison created an uncomfortable question. Was there a forgotten continuation of technological traditions between the Indus Valley world and southern India? Officially, the collapse of the Indus cities around 1900 BCE supposedly ended that urban culture. Yet Keezhadi displayed signs of organized civic engineering appearing again far to the south centuries later. Historians still debate whether this was coincidence, independent development, or evidence of a longer chain of technological continuity that has largely disappeared from written history. Another mystery emerged from the sheer scale of production visible at the site. Keezhadi was not merely a residential settlement. Archaeologists uncovered furnaces, industrial waste, spinning tools, bead-making evidence, iron artifacts, and traces of textile dyeing. Thousands of artifacts suggested a highly specialized economy where labor was divided into skilled crafts. Some glass beads discovered at Keezhadi possessed remarkable uniformity and polish, requiring controlled heating temperatures and advanced material knowledge. Producing such items consistently would have demanded experienced craftsmen and stable industrial organization. Yet the most puzzling technological mystery at Keezhadi revolves around its fired brick engineering. Across the excavation zone, archaeologists found enormous quantities of kiln-fired bricks with surprisingly consistent dimensions and durability. Many structures survived despite more than 2,000 years of tropical heat, monsoon rainfall, soil pressure, and groundwater movement. In modern tropical climates, poorly fired bricks often deteriorate rapidly due to moisture expansion, salt penetration, and repeated heating cycles. Yet Keezhadi's bricks retained structural integrity far beyond what researchers expected. Scientific analysis showed that many of these bricks were fired at relatively high and carefully controlled temperatures. Achieving this level of consistency without modern kilns would have required an advanced understanding of airflow regulation, combustion timing, and clay composition. Ancient brickmakers would have needed to maintain stable heat for long periods, possibly exceeding temperatures of 700 to 900 degrees Celsius. Even slight fluctuations during firing could weaken entire batches, yet Keezhadi's bricks display unusual uniformity across large areas. This raises an even greater question. How did an ancient settlement sustain industrial-scale brick production without exhausting local fuel resources? Large brick industries consume enormous amounts of wood or biomass fuel. Some estimates from experimental archaeology suggest that producing thousands of fired bricks could require several tons of fuel material. Southern Tamil Nadu was not known for limitless forest resources on the scale of ancient Mesopotamia or the Roman Empire. Somehow, Keezhadi maintained enough energy production to support large-scale firing operations while continuing urban expansion. Researchers also noticed that some bricks appeared unusually resistant to water damage. The clay mixtures may have contained carefully selected mineral compositions that improved durability under humid conditions. Certain samples suggest a sophisticated understanding of sediment selection from the Vaigai River basin. In some cases, the bricks show less cracking and erosion than medieval bricks produced many centuries later in similar environments. This creates a technological paradox. Why did certain ancient construction methods achieve durability levels that later builders often failed to reproduce consistently? The engineering of Keezhadi's ring wells deepened the mystery further. These cylindrical wells were constructed from stacked terracotta rings, fitted with remarkable precision. Some remained structurally intact after centuries underground. Their circular geometry distributed surrounding soil pressure evenly, preventing collapse. Similar concepts are still used in modern underground shaft engineering. Producing perfectly curved terracotta sections repeatedly would have required precise shaping techniques and controlled kiln firing. The tolerances were small enough that poorly made rings would crack under underground pressure. Water management itself appears far more sophisticated than expected for the period. Keezhadi's inhabitants did not simply depend on the nearby Vaigai River. Archaeologists discovered evidence of integrated drainage systems and controlled water distribution. Wastewater channels suggest an understanding of sanitation and runoff management uncommon in many ancient settlements of comparable age. In some areas, the city's drainage planning resembled principles seen in far older Bronze Age urban centres. The discovery of Tamil Brahmi inscriptions added another layer to the puzzle. Writing scratched onto pottery fragments indicated that literacy, may have been more widespread than historians previously believed. Rather than being restricted to royal courts or priests, written communication may have existed among merchants, craftsmen, or ordinary urban residents. If correct, Keezhadi represented not merely an isolated settlement, but a literate and economically connected society with organized administration. This became especially controversial because the dates associated with Keezhadi challenge older assumptions about the timeline of South Indian civilization. Traditional historical models often portray the Deep South as becoming urbanized later than northern India. Keezhadi disrupted that narrative entirely. Some researchers now argue that southern India may have developed complex urban culture independently and earlier than once assumed. Trade evidence intensified the mystery. Certain artifacts suggest participation in long-distance commercial networks stretching across the Indian Ocean. Ancient Tamil regions were known to trade with the Roman Empire centuries later, exporting spices, pearls, textiles, and precious stones. But Keezhadi hints that complex trade infrastructure may already have existed before these connections became historically documented. If merchants and industrial workshops operated here at such an early date, then southern India's economic integration with the wider ancient world may have begun far earlier than historians expected. Do you think Keezhadi was simply a forgotten ancient city? Or could it be evidence that entire advanced civilizations disappeared from history far more completely than we realize? Share your thoughts in the comments below. Modern-day Kosovo hides the ruins of Ulpiana, one of the strangest engineering mysteries of the Roman world. At first glance, Ulpiana appears to be another forgotten Roman city buried beneath centuries of destruction. But beneath its collapsed basilicas and broken roads lies evidence of something far more difficult to explain. A city with advanced urban planning, underground heating systems, earthquake-resistant foundations, and metallurgical technology that may have exceeded what historians once believed possible for the Balkans nearly 2,000 years ago. The greatest mystery of all is not that Ulpiana existed, but how its engineers achieved such precision using tools and resources supposedly limited by the ancient world. Ulpiana was officially identified during archaeological surveys in the 19th century, but systematic excavations expanded dramatically during the 20th century as researchers uncovered massive public buildings, Roman roads, water systems, workshops, and Christian basilicas spread across a surprisingly organized urban layout. Each excavation season revealed more evidence that Ulpiana was not a minor provincial settlement. Instead, it may have functioned as one of the most technologically sophisticated urban centers in the Central Balkans during the late Roman Empire. One of the first mysteries that shocked archaeologists was the city's geometric planning. Ulpiana followed a near-perfect orthogonal grid system, similar to the urban layout seen in Roman cities like Timgad or Pompeii. But unlike those cities, Ulpiana stood in a region with uneven terrain and frequent seismic instability. Despite this, major roads remained aligned with remarkable precision. Some streets deviated by only a few degrees after nearly 2 millennia of earthquakes, erosion, invasions, and structural collapse. Researchers studying Roman surveying techniques believe engineers may have used highly advanced Groma-based alignment systems combined with astronomical positioning methods. Yet the consistency across the city still raises questions about how such precision was maintained without modern instruments. Beneath those roads, archaeologists uncovered another technological puzzle, an extensive underground drainage and water management network. Stone sewers ran beneath major streets with carefully calculated gradients that allowed wastewater to flow continuously without generating excessive erosion. In several sections, the stone blocks fit together so tightly that even modern researchers were surprised by the level of cutting precision. Similar hydraulic sophistication existed in larger Roman cities like Rome or Ephesus, but Ulpiana was located far from the imperial core. The existence of infrastructure on this scale suggests the transfer of highly specialized engineering knowledge deep into the Balkans much earlier than historians previously assumed. The city also contained evidence of hypocaust systems, one of Rome's most advanced heating technologies. Hot air circulated beneath floors and through hollow wall spaces to heat baths and public buildings. While hypocaust systems existed elsewhere in the Roman world, some of the construction materials discovered in Ulpiana displayed unusual durability. Laboratory analysis of surviving bricks revealed high resistance to thermal stress and moisture, despite exposure to centuries of environmental damage. Certain clay mixtures appear to contain mineral compositions that improved heat tolerance beyond what researchers expected from standard Roman brick production. Some scientists now suspect local craftsmen may have modified traditional Roman formulas using Balkan mineral resources to create more resilient building materials. Another mystery surrounds Ulpiana's apparent resistance to earthquakes. Historical records indicate the region experienced multiple destructive seismic events during antiquity, including a major earthquake in the year 518 CE that devastated much of the Balkans. Yet parts of Ulpiana's foundations survived remarkably well. Excavations revealed layered construction techniques using combinations of stone and gravel and mortar that may have dispersed seismic energy rather than transmitting it directly upward into walls. Similar engineering principles appear in much later earthquake-resistant structures, including some Inca constructions in Peruvian Byzantine architecture in Anatolia. The possibility that Roman engineers in Ulpiana intentionally designed foundations to absorb ground movement remains heavily debated among archaeologists. But the greatest and most controversial mystery of Ulpiana involves metallurgy and furnace temperature control. The city stood near mineral-rich regions containing lead, silver, iron, and other valuable ores. Archaeological surveys uncovered traces of workshops, slag deposits, smelting residues, and metal processing tools, suggesting that Ulpiana was deeply connected to industrial-scale production. What surprised researchers was the consistency of several metal artifacts recovered from the site. Scientific analysis showed unusually stable alloy compositions, implying precise control over furnace conditions during smelting and forging. This should not have been easy. Ancient furnaces were notoriously difficult to regulate. Without thermometers or modern airflow systems, maintaining consistent temperatures above 1000 degrees Celsius required extraordinary skill. Yet some iron and bronze artifacts from Ulpiana show metallurgical uniformity that rivals production standards from much later periods. Certain samples displayed carbon distribution suggesting controlled heating cycles rather than random exposure to fluctuating fire conditions. Researchers comparing Ulpiana's metallurgical remains to Roman industrial centres in Britain and Hispania noticed another anomaly. The slag composition indicated extremely efficient ore separation. In simple terms, the furnaces extracted a surprisingly high percentage of usable metal while minimizing waste. This level of efficiency required not only advanced furnace design, but also deep understanding of airflow, fuel management, and mineral chemistry. Some theories suggest that Ulpiana's metallurgists may have used specialized furnace chambers capable of sustaining hotter and more stable combustion zones than typical Roman provincial workshops. Others believe the key may have been the local mineral composition itself. Certain Balkan ores contain tracer elements that alter smelting behavior under high heat, potentially allowing craftsmen to achieve cleaner metal extraction with fewer impurities, but even this explanation does not fully solve the mystery, because successful smelting still depended on extremely careful control of oxygen flow and temperature balance. Experimental archaeologists attempting to recreate Roman furnaces have discovered how difficult this process actually was. Small changes in airflow could reduce furnace temperatures by hundreds of degrees. Excess oxygen could weaken the metal, while insufficient oxygen could leave large quantities of unprocessed ore trapped inside the slag. Yet Ulpiana's metalworkers appear to have maintained remarkable consistency over extended production periods. Even more puzzling are indications that some workshops may have operated continuously for long durations. Continuous furnace operation required coordinated fuel supply systems and precise labour organisation. Producing enough charcoal alone would have demanded large-scale resource management across surrounding forests. This suggests Ulpiana may not have been merely a provincial town, but an industrial centre integrated into major Roman economic networks. The mystery deepens further when researchers compare Ulpiana to other Roman cities destroyed during the collapse of imperial authority in the Balkans. In many regions, technological complexity declined rapidly after repeated invasions during the 5th and 6th centuries, but evidence from Ulpiana suggests that sophisticated engineering and industrial production continued even during periods of instability. Some rebuilt structures actually use stronger materials than earlier phases of construction, implying that local craftsmen continued improving techniques rather than losing them. What do you think about Ulpiana's lost engineering knowledge? Could ancient civilizations have mastered technologies far beyond what we officially recognize today? Share your thoughts in the comments below. Buried within the humid floodplains of San Luis Potosí, Mexico, Tamtok remained lost beneath vegetation and layers of sediment for centuries. At first glance, it appeared to be just another ceremonial center of the ancient Huastec civilization. But once archaeologists began mapping the site, an unsettling pattern emerged. The city's plazas, mounds, and monuments appeared aligned with astronomical events, with a precision that should have been impossible for a society without metal instruments, optical devices, or written scientific records. Even more mysterious, Tamtok was built in one of the wettest and most unstable environments in Mesoamerica, yet many of its earth structures survived for more than 2,000 years. Today, researchers still debate whether the technological sophistication of Tamtok has been drastically underestimated. Although local communities had known about strange mounds in the region for generations, large-scale archaeological investigation only began in the 20th century. Located within the Huasteca region near the Tampan River system, Tamtok covers more than 130 hectares, making it one of the largest Huastec ceremonial centers ever discovered. Excavations intensified during the 1960s and later under Mexican archaeologist Guillermo Ekholm and subsequent teams from the National Institute of Anthropology and History. What shocked researchers was not only the scale of the city, but the density of engineered platforms, artificial elevations, canals, and ceremonial structures hidden beneath layers of sediment. Some sections appeared intentionally raised to resist seasonal flooding. Others revealed evidence of long-term urban planning rather than random settlement growth. Over time, archaeologists uncovered more than 70 major mounds, stone monuments, carved sculptures, and sophisticated ceremonial zones that suggested Tamtok had once been a major intellectual and spiritual center of ancient Mexico. The most controversial mystery surrounding Tamtok involves its astronomical layout. Many of the city's principal structures appear deliberately aligned with solar events, particularly the sunrise positions during equinoxes and solstices. Researchers studying the orientation of plazas and ceremonial axes found angular deviations so small that they rivaled alignments seen at far more famous Mesoamerican sites such as Teotihuacan and Chichen Itza. This immediately raised a difficult question. How could the Huastec civilization achieve such precision without known advanced instruments? Unlike the Maya, the Huastec left behind very few surviving codices or mathematical texts. There are no surviving astronomical tables comparable to the Dresden Codex. Yet Tamtok suggests systematic sky observation over long periods of time. Some alignments correspond closely to solar cycles associated with agriculture, seasonal flooding, and ritual calendars. Archaeologists believe certain ceremonial pathways may have functioned as observational corridors, allowing priests to track the movement of celestial bodies across the horizon. The mystery becomes even deeper when comparing Tamtok to other ancient civilizations. At Stonehenge in England, solar alignment required generations of observation across open landscapes. At Machu Picchu in Peru, the Incas carved solar observation points directly into mountain stone. But Tamtok existed in a humid floodplain environment filled with vegetation, shifting soil and unstable terrain. Maintaining accurate long-term astronomical reference points in such conditions should have been dramatically harder. Some researchers propose that the Huastec used elevated observation platforms combined with horizon markers placed at strategic points. Others believe the city's orientation reflects inherited astronomical knowledge passed through older Mesoamerican networks. Yet none of these explanations fully accounts for the consistency of the alignments across multiple structures. One of the most debated artifacts connected to this mystery is Monument 32, a carved stone slab discovered at the site. The monument contains circular depressions and symbolic patterns that some researchers interpret as representations of celestial cycles. Several theories suggest the markings could track Venus movements, lunar cycles, or ritual calendar intervals. Venus was extraordinarily important throughout Mesoamerica because its appearances were associated with war, agriculture, and divine timing. If Monument 32 truly encoded astronomical information, it would imply that the Huastec possessed a far more sophisticated understanding of celestial mechanics than previously believed. Modern archaeoastronomy studies have attempted to reconstruct the ancient sky visible from Tamtok around 2,000 years ago. Simulations indicate that several key alignments would indeed correspond closely with significant solar events during that period, but whether these alignments were intentional scientific achievements or ritual symbolism remains fiercely debated. Another mystery that continues to puzzle researchers is how Tamtok survived in such a hostile hydrological environment. The Huasteca region experiences intense rainfall, periodic flooding, and unstable sediment conditions. Most earthwork settlements in similar climates erode rapidly over centuries, yet many of Tamtok's elevated platforms remain recognizable today after more than 2 millennia. Archaeologists discovered evidence that large portions of the city were artificially raised above the floodplain. Soil analysis revealed layered construction techniques using compacted earth mixed with varying sediment densities. Some specialists believe these layers acted similarly to primitive geotechnical stabilization systems, dispersing water pressure while reducing erosion. The engineering becomes even more impressive considering the scale involved. Several platforms measure dozens of meters across and required the movement of enormous quantities of soil without wheeled transport or draft animals. Researchers estimate that constructing the largest ceremonial mounds would have required coordinated labor forces operating over decades. Comparisons with other ancient flood control societies make the mystery even stranger. Mesopotamian cities depended heavily on canals and stone reinforcement. Ancient Egyptian settlements relied on predictable Nile flooding cycles, but Tamtok functioned within a tropical flood system far less stable and far more destructive. Some archaeologists argue that the Huastec may have developed localized environmental engineering methods specifically adapted to wetland conditions. Even today, modern civil engineering projects in floodplain regions require careful drainage calculations and soil stabilization techniques. The fact that ancient builders achieved long-term structural survival using mostly earth and organic materials continues to astonish specialists. Among the most visually disturbing discoveries at Tamtok are its enormous female stone sculptures. Unlike many Mesoamerican ceremonial centers dominated by warrior imagery or male rulers, Tamtok contains an unusually high concentration of female representations. Some statues weigh several tons and display anatomical proportions carved with surprising precision. This has led researchers to propose that Tamtok may have functioned as a ceremonial centre linked to fertility, water worship, lunar cycles, or female deities connected to agriculture. Others believe the sculptures represent elite priestesses or dynastic figures rather than gods. But the greatest mystery is technological. The region surrounding Tamtok lacks abundant high-quality stone sources. Transporting multi-ton monuments across wet terrain without metal machinery would have been extraordinarily difficult. Some statues also display smooth surface finishing techniques that appear more advanced than expected from the available tools of the period. The problem mirrors debates seen at sites like Olmec San Lorenzo, where colossal basalt heads were transported over massive distances. Yet Tamtok remains even more puzzling because of its swamp-like environment. Researchers still cannot fully explain how these enormous sculptures were moved, erected, and preserved. What do you think Tamtok truly represents? A forgotten centre of advanced ancient knowledge, or evidence that modern history has underestimated ancient civilizations for centuries? Share your thoughts and theories in the comments below. Pukara de Quitor stands on a steep rocky hill just north of San Pedro de Atacama in northern Chile, inside one of the harshest environments ever inhabited by humans. The Atacama Desert receives less than 1 millimeter of rainfall annually in some regions, and certain weather stations there have recorded years without measurable rain at all. Yet on the barren volcanic landscape, archaeologists discovered the remains of a fortified settlement built centuries before the arrival of the Spanish. The site first attracted serious archaeological attention during the late 19th and early 20th centuries, when explorers and researchers studying the ancient Atacameño civilization documented more than 100 interconnected stone structures climbing the mountainside. Excavations later revealed defensive walls, narrow access routes, storage areas, lookout positions, and residential sectors built directly into the natural rock formation. At first glance, the ruins appear crude compared to places like Machu Picchu or Sacsayhuaman, but the deeper researchers studied Pukara de Quitor, the stranger it became, because the true mystery was not decorative beauty. The mystery was survival. Everything about this fortress suggests engineering decisions specifically adapted for one of the most unforgiving environments on Earth. And some of those decisions still are not fully understood. The most astonishing aspect of Pukara de Quitor is the terrain itself. The fortress was not built on a flat plateau. It was constructed across an uneven volcanic hillside filled with unstable rock, steep inclines and narrow ridges. Even modern construction on similar terrain requires geological surveys, stabilization systems, drainage planning, and heavy equipment. Yet centuries ago, the Atacameño people somehow transformed this hostile slope into a layered defensive complex. Researchers estimate that the site once contained more than 100 stone structures connected through elevated terraces and narrow passageways. Many walls were built without mortar using irregular volcanic stones gathered from the surrounding environment. Under normal conditions, such dry stacked walls should gradually collapse due to gravity, erosion, thermal expansion, and seismic activity. But many sections still survive. This becomes even more difficult to explain when considering the climate of the Atacama. Daytime temperatures can exceed 30 degrees Celsius before falling close to freezing at night. That constant thermal expansion and contraction slowly destroys most exposed stone architecture over time. Modern engineers consider repeated thermal cycling one of the major causes of structural fatigue in desert environments. Yet Pukara endured for centuries. Some archaeologists believe the builders intentionally designed the walls to flex slightly under pressure, rather than resist movement rigidly. Instead of forcing the mountain into geometric order, they adapted each structure to the existing terrain. The walls follow natural fractures in the rock, distributing weight across uneven surfaces instead of fighting against them. This philosophy resembles engineering techniques later associated with Inca construction. At sites like Machu Picchu, builders integrated architecture directly into mountain geometry to reduce earthquake damage. But Pukara de Quitor predates major Inca expansion into the region. That raises an unsettling possibility. Perhaps sophisticated mountain engineering traditions already existed in the Andes long before historians assumed. Even more mysterious is the logistics behind construction. Transporting large quantities of stone uphill at an altitude of over 2,400 meters in an arid desert would have required enormous labor coordination. There were no draft animals capable of hauling massive loads like horses or oxen before European arrival. Llamas could carry only limited weight, usually less than 40 kilograms. Everything else depended on human labor. And still an entire fortress emerged from the mountain. Pukara de Quitor was not merely a village surrounded by walls. It was a carefully designed military position. The fortress overlooks the narrow approaches leading into the San Pedro oasis, giving defenders visual control over movement through the valley. Attackers climbing towards the site would have been forced through restricted pathways exposed from above. Defensive walls were layered vertically so that even if one section fell, higher levels could continue resisting. Military historians studying ancient fortifications often compare defensive advantage through elevation ratios. At Pukara, defenders occupied terrain that naturally multiplied the effectiveness of even small groups. A handful of warriors stationed above could potentially repel much larger attacking forces struggling uphill across exposed rock. But this creates another mystery. Why would a relatively small desert society invest so much labor into military infrastructure? One theory suggests constant warfare between competing oasis communities. Another argues the fortress protected caravan trade routes connecting the Atacama with the Andes and Pacific coast. Archaeological evidence confirms long-distance exchange networks involving copper, turquoise, obsidian, shell materials, and hallucinogenic plants. However, some researchers believe the scale of the defences exceeds what would normally be expected for local tribal conflicts alone. The site appears designed for prolonged resistance, and history proved that design worked. When Spanish forces under Francisco de Aguirre attacked the fortress in the 16th century, indigenous defenders reportedly resisted fiercely despite facing steel weapons and cavalry. Even with superior technology, conquering the position was difficult because the terrain itself functioned as part of the fortress. The mountain had become a weapon. The Atacama Desert is often described as the closest environment on Earth to Mars. NASA has repeatedly used parts of the region to test instruments intended for Martian exploration because of the extreme dryness and mineral composition. In some areas, microorganisms survive only deep beneath salt crusts where traces of moisture remain trapped. Yet ancient people lived here. That alone is extraordinary. Excavations around Pukara de Quitor uncovered storage structures, agricultural evidence, irrigation traces, and preserved organic material. Researchers discovered that nearby oasis systems fed by underground Andean snowmelt allowed limited farming despite the surrounding desert. But the scale of coordination required remains difficult to explain. Water management in hyper-arid environments is incredibly complex. A single miscalculation can destroy entire communities. Modern desert agriculture depends heavily on pumps, reservoirs, climate, monitoring, and engineered distribution systems. Ancient Atacameño societies had none of these technologies, and yet they survived for centuries. Some scientists believe the people of the region developed highly specialized environmental knowledge passed through generations. They may have understood underground water movements, seasonal melt patterns, and evaporation behavior with remarkable precision. There is also evidence suggesting strategic food preservation techniques. The extreme dryness naturally mummifies organic matter, dramatically slowing bacterial decay. Some researchers propose the inhabitants may have intentionally used the desert climate itself as a preservation system for stored crops and supplies. In other words, the environment that should have killed them may have become part of their technology. Seen from a distance, Pukara de Quitor almost vanishes into the surrounding landscape. This is one of the fortress's most overlooked mysteries. Unlike monumental civilizations that emphasize visibility and symbolic power, the builders here appear to have prioritized concealment and terrain integration. The stone coloration matches the volcanic hillside so closely that many structures become difficult to distinguish until viewed nearby or from above. Modern military camouflage operates on similar principles, breaking recognizable outlines, reducing visual contrast, and merging artificial structures with natural surroundings. Whether intentional or not, Pukara achieves exactly that effect. The defensive advantage would have been enormous. Approaching enemies unfamiliar with the terrain could have difficulty identifying entrances, defensive positions, or the true scale of the settlement until already exposed. Again, this suggests planning beyond simple survival. It suggests strategic engineering. What do you think? Was Pukara de Quitor simply a desert fortress, or evidence that ancient civilizations understood environmental engineering far better than we realize today? Share your thoughts in the comments below. On the southwestern edge of Orongo, where cliffs plunge more than 300 meters into the Pacific Ocean and volcanic winds strike with almost uninterrupted force, an ancient ceremonial village was built in a place many engineers today would consider irrational. Perched directly on the rim of the Ranokau crater, Orongo remains one of the most mysterious archaeological sites in Polynesia. What makes the site extraordinary is not massive pyramids or giant temples, but something far harder to explain. A small isolated society appears to have mastered environmental engineering techniques centuries ahead of what researchers expected from a remote oceanic culture. Even today, archaeologists, geologists, and structural engineers continue debating how its stone architecture survived one of the harshest coastal environments on Earth. Orongo first drew serious scientific attention in the 19th century when European explorers documented strange low stone houses and hundreds of petroglyphs carved into volcanic rock overlooking the sea. Systematic archaeological work expanded during the 20th century, particularly through investigations by Catherine Routledge in the early 1900s and later expeditions led by William Malloy. Excavations revealed that Orongo was not an ordinary settlement, but the ceremonial centre of the Birdman cult, a powerful ritual system that dominated Rapa Nui society after the decline of the Moai building era. The village sits beside the crater lake of Ranokau, one of the island's main freshwater sources, while directly facing the offshore islets Motu Nui, Motu Iti and Motu Kau Kau. This location alone created a logistical paradox. The terrain combines unstable volcanic slopes, violent ocean winds, salt corrosion, seismic activity, and dangerous elevation changes. Yet Orongo's structures endured for centuries with surprising structural stability. The first great mystery surrounding Orongo is its improbable construction site. Most ancient coastal settlements were built in protected harbours or valleys where resources and shelter were easier to secure. Orongo was built at the exact opposite extreme. Wind speed around the crater rim can exceed 80 km per hour during storm conditions, while the cliffside experiences constant salt-laden air capable of accelerating stone erosion. Geological surveys have shown that the volcanic tuff and basalt around the crater are highly fractured and vulnerable to long-term weathering. In practical engineering terms, this should have been a poor place for durable architecture. Yet dozens of ceremonial houses survived long enough to remain identifiable centuries later. Researchers comparing Orongo to other Polynesian settlements noticed something remarkable. The village appears intentionally designed to cooperate with the environment instead of resisting it directly. This becomes most visible in what many experts consider Orongo's greatest unsolved technological mystery: its wind-resistant and earthquake-resistant architecture. The houses at Orongo are extremely low to the ground, often only a little over 1 meter high internally. Early explorers incorrectly assumed the buildings reflected primitive limitations. Modern structural analysis suggests the opposite. Their low aerodynamic profile dramatically reduced lateral wind pressure. Instead of presenting vertical walls to the ocean winds, the structures hugged the terrain like stone shells. Some engineers compare the concept to partially buried military bunkers, or aerodynamic storm-resistant shelters used in modern extreme weather regions. The roofing system is even more astonishing. The roofs were formed using overlapping basalt slabs arranged into corbel-like vaults. This technique distributed compressive loads outward while minimizing structural weak points. In seismic engineering, low center of gravity structures perform better during ground movement because they reduce overturning forces. Rapa Nui lies in a tectonically active region connected to volcanic processes, meaning ancient builders likely experienced periodic tremors. The architecture at Orongo unintentionally, nor perhaps intentionally, follows principles similar to anti-seismic construction used thousands of years later in earthquake-prone civilizations. What makes this difficult to explain is the technological context. The Rapa Nui people possessed no iron tools, no wheeled transport, and no draft animals. Yet many basalt slabs used in the roofs weigh hundreds of kilograms. Transporting them uphill across volcanic slopes would have required coordinated labor, advanced planning, and deep understanding of stone balancing techniques. Experimental archaeology has attempted to replicate similar transportation methods using ropes and wooden sled systems, but the energy requirements remain enormous relative to the island's small population estimates. Some researchers believe Orongo's builders possessed highly specialized construction knowledge passed through generations, knowledge later lost after societal collapse and European contact. Another extraordinary feature is the precision of water management around the crater edge. Heavy Pacific rainfall can rapidly destabilize volcanic slopes through runoff erosion. However, surveys of Orongo revealed carefully integrated drainage patterns between structures. Stone channels appear positioned to redirect water away from foundations while minimizing soil displacement. Similar environmental adaptation techniques are seen in Inca mountain architecture at sites like Machu Picchu, where drainage engineering was critical to slope stability. The difference is scale. The Inca Empire possessed enormous labor resources and continental infrastructure. Rapa Nui was an isolated island thousands of kilometers from major civilizations. That comparison makes Orongo's engineering even more difficult to contextualize historically. The second major mystery involves the hundreds of petroglyphs carved throughout the ceremonial complex. Orongo contains one of the densest concentrations of rock art in Polynesia, especially depictions of Tangata Manu, the birdman figure central to the island's ritual system. Many carvings were etched into hard basalt surfaces using only stone tools. Some display surprisingly smooth curvature and proportional consistency. Replication experiments conducted by archaeologists demonstrated how time-consuming such carvings would have been with obsidian or basalt chisels. Yet the sheer number of petroglyphs suggests long-term organized artistic production. Several glyphs align visually with the offshore islet Motu Nui and with seasonal solar positions. This has led some archaeoastronomers to suspect Orongo also functioned as a ritual observation centre linked to celestial cycles. Polynesian navigators already possessed advanced oceanic navigation skills based on stars, currents, wave reflection patterns, and bird migration. Some scholars believe the Birdman ceremonies may have incorporated astronomical timing systems connected to seabird migration seasons. If true, Orongo may represent a fusion of religious architecture, environmental engineering, and observational astronomy within a single ceremonial landscape. The Birdman ritual itself introduces another layer of mystery. Competitors descended nearly vertical cliffs from Orongo to the ocean below, then swam through shark-filled waters to Motu Nui in search of the first Manutara egg of the season. The winner's sponsor became the island's ceremonial leader for the year. From a survival perspective, the ritual bordered on suicidal, yet it continued for generations. Oceanographers studying the currents around Ranokau describe the waters as highly unpredictable due to wave reflection from volcanic cliffs and shifting Pacific swells. Successfully completing the journey required extraordinary physical endurance and intimate knowledge of marine conditions. This suggests the Rapa Nui possessed sophisticated practical understanding of seasonal weather systems and ocean dynamics long before modern meteorology existed. One of the deepest mysteries connected to Orongo involves the possibility of symbolic communication systems linked to Rongorongo, the undeciphered script of Rapa Nui. Some Birdman imagery resembles motifs found on surviving Rongorongo tablets. If Rongorongo represents a true writing system rather than symbolic memory aids, then Rapa Nui may have independently developed one of the few known scripts in human history without direct influence from major literate civilizations. That possibility would radically reshape assumptions about intellectual development in isolated Polynesian societies. Unfortunately, most Rongorongo artifacts were lost during colonial disruption, disease outbreaks, and missionary destruction in the 19th century, leaving researchers with too little material for complete decipherment. What do you think Orongo truly represents? A forgotten engineering breakthrough, a lost ceremonial science, or evidence that the ancient Rapa Nui understood nature far better than we realize today? Share your thoughts in the comments below. Cold winds sweep across the Kashmir Valley, where an ancient settlement near Srinagar revealed one of the strangest archaeological discoveries in South Asia. Located about 16 kilometers northeast of the city at an elevation of roughly 1,800 meters above sea level, Burzahom was first identified during the 1930s and later excavated extensively by the Archaeological Survey of India between 1960 and 1971. Archaeologists initially believed the site was a small prehistoric village. But the deeper they excavated, the stranger the settlement became. Beneath the surface were deep underground pit houses, advanced bone tools, mysterious standing stones, and engineering techniques that seemed almost impossible for the Stone Age society living in one of the harshest climates of ancient India. The name Burzahom means place of birch in Kashmiri, yet beneath that quiet landscape researchers uncovered evidence of a community that survived for nearly 2,000 years, from around 3000 BCE into the early Bronze Age. What shocked archaeologists was not simply the age of the settlement, it was the level of environmental adaptation and technical precision hidden within it. Because the deeper excavators went, the less Burzahom behaved like a normal Neolithic site. The most famous mystery of Burzahom is its underground dwellings. Large circular and oval pits were cut directly into the hard soil, some descending nearly 4 meters deep. Stair-like footholds were carved into the side so residents could climb in and out. Post holes indicated wooden roofing systems once covered the structures, turning them into semi-subterranean homes. At first glance, archaeologists assumed these pits were primitive shelters against winter cold. But later thermal studies suggested something much more sophisticated. Modern earth-sheltered architecture operates on a simple principle. Soil acts as a thermal buffer. At depths of several meters, underground temperatures remain relatively stable year-round. In Kashmir, where winter temperatures can drop below freezing and summer temperatures fluctuate dramatically, this design would have created a naturally insulated environment requiring far less fuel for heating. The problem is accuracy. The Burzahom pits were not randomly dug holes. Many displayed carefully angled walls, smooth-cut surfaces, and consistent structural depth. Some pits even appeared positioned to minimize water infiltration during snowmelt seasons. In modern engineering, underground structures require knowledge of drainage pressure, soil collapse risk, and thermal retention. Yet the people of Burzahom supposedly possessed only stone and bone tools. Even more puzzling is durability. Kashmir's soil undergoes seasonal freeze-thaw cycles capable of destabilizing modern foundations. Yet several pit structures survived recognizable for nearly 5,000 years. Archaeologists still debate how these deep excavations resisted collapse long enough for generations of habitation. Some researchers compare Burzahom's pit architecture to Neolithic settlements in Siberia and northern China. But Burzahom lies thousands of kilometers away from those regions, raising another unresolved question. Did similar survival technologies emerge independently? Or was ancient knowledge travelling across Eurasia far earlier than historians once believed? One of the greatest surprises at Burzahom was the enormous quantity of bone tools. Archaeologists uncovered harpoons, needles, arrowheads, awls, and spear points crafted from animal bones with astonishing symmetry. Bone is an extremely difficult material to shape precisely. Unlike stone, it fractures unpredictably under pressure. Producing thin, balanced tools without splitting the material requires careful control of force angle. Yet many Burzahom artifacts show polished surfaces and near-identical dimensions. Microscopic analysis revealed evidence of repeated grinding and smoothing phases, suggesting a surprisingly advanced production process. Some needles were thin enough to imply the stitching of animal hides or woven materials. Others displayed drilled perforations with remarkably circular openings. This is where the mystery deepens. Creating consistent holes in bone without metal drill bits presents a major technical challenge. Experimental archaeologists attempted reproductions using stone points and abrasive sand mixtures. While possible, the process was painfully slow and difficult to standardize. Yet Burzahom produced these objects in significant quantities. The spearheads are equally mysterious. Several display aerodynamic forms similar to much later hunting technologies. Researchers studying impact fractures concluded that many were designed specifically for high-velocity penetration, rather than simple stabbing weapons. That implies deep empirical understanding of motion, balance, and material resistance, concepts normally associated with far more technologically developed societies. Compared to many contemporary Neolithic cultures in South Asia, Burzahom's bone industry appears unusually specialized. Some archaeologists even describe it as resembling Arctic survival technologies more than typical Indian Neolithic traditions. Among the most emotionally disturbing discoveries at Burzahom were burials containing both humans and animals. Dogs were found intentionally buried beside human bodies, sometimes in positions suggesting ritual placement rather than disposal. This has led some researchers to argue that Burzahom preserves some of the earliest evidence of emotional human-animal relationships in the Indian subcontinent. But the implications go beyond symbolism. If dogs were already domesticated companions here nearly 5,000 years ago, the residents likely relied on them for hunting, protection, or transport assistance in harsh terrain. The Kashmir Valley during the Neolithic period was heavily forested and populated by dangerous wildlife including wolves, bears, and large deer species. Faunal remains show that Burzahom hunters pursued an unusually wide range of animals. Hunting at this scale would have required organized cooperation, tracking systems, and seasonal planning. This was not a tiny, isolated tribe barely surviving winter. It was a stable society capable of long-term adaptation. Some anthropologists believe the complexity of these burial rituals hints at early spiritual systems tied to animals and celestial cycles. Others argue it reflects social stratification already emerging during the Neolithic era. Either way, Burzahom forces archaeologists to reconsider how socially advanced early mountain communities may have been. Perhaps the most controversial artifact from Burzahom is a carved stone slab depicting a hunting scene beneath two circular objects in the sky. Some scholars interpret the image as symbolic or mythological. Others believe it may represent an actual atmospheric or astronomical phenomenon. One theory suggests the carving depicts a sundog, an optical illusion caused by ice crystals refracting sunlight in extremely cold environments. Sundogs can create the appearance of multiple suns in the sky and are still observed in polar and high-altitude regions today. If correct, this would mean the people of Burzahom carefully observed and recorded rare atmospheric events thousands of years ago. What makes the carving remarkable is its detail. The positioning of hunters, animals, and celestial objects appears deliberate, rather than abstract. Compared to many contemporary rock art traditions, the composition is unusually structured. There is another unsettling possibility. Some researchers argue the dual celestial symbols may indicate early cosmological beliefs connected to seasonal survival. In extreme climates, understanding solar movement would have been critical for predicting migration patterns, snow conditions, and planting cycles. If Burzahom's residents tracked the sky systematically, they may have possessed a practical observational astronomy long before formal astronomical traditions emerged in ancient India. In later occupational phases, Burzahom's residents erected large standing stones around the settlement. These megaliths are not as massive as those at Stonehenge or the Moai statues of Rapa Nui, but their existence in Kashmir creates major engineering questions. Some stones weighed several hundred kilograms. Transporting them across uneven ground without wheels, metal tools, or draft animals would have required coordinated labour and surprisingly advanced mechanical understanding. The soil conditions of the Kashmir Valley make the challenge even greater. Wet ground and seasonal freezing reduce stability, making upright placement difficult. Yet several stones remained standing for millennia. Researchers still debate whether these megaliths served ritual, astronomical, or territorial purposes. Their exact alignment patterns remain poorly understood due to erosion and incomplete preservation. But their presence proves one thing clearly: Burzahom evolved far beyond a simple pit-dwelling village. What do you think Burzahom really represents? A surprisingly advanced Stone Age society, or evidence that ancient human knowledge was far more sophisticated than history admits? Share your thoughts in the comments below. On the rocky highlands of northern Axum, far above the dry valleys of East Africa, lies one of the least understood hydraulic systems of the ancient world. The civilization of Axum built enormous reservoirs capable of storing vast amounts of water nearly 2,000 years ago, in an environment where seasonal rain could destroy entire settlements within hours. What makes the mystery even stranger is not simply that these reservoirs existed, but that many of them held water with remarkable efficiency despite being carved into porous volcanic ground. Even today, archaeologists and engineers still debate the same unsettling question: how did the Axumites waterproof massive reservoirs centuries before modern hydraulic engineering existed? The reservoirs of Axum attracted scientific attention during 19th century European expeditions into Ethiopia, but serious archaeological investigation expanded during the 20th century as researchers began mapping the ruins of the ancient kingdom of Axum. Among the most important discoveries was the reservoir known as Mai Shum, located near the ancient royal city. Excavations revealed carefully shaped embankments, stone retaining walls, drainage channels, and signs of large-scale hydraulic planning. Later surveys using satellite mapping and topographic analysis suggested that Maishum may once have been connected to a broader network of canals and runoff control systems extending across the surrounding plateau. One of the first mysteries surrounding the Axum reservoirs is the sheer difficulty of building such structures in northern Ethiopia's terrain. The region experiences extreme seasonal variation. During the rainy season, torrential downpours can rapidly flood valleys and erode hillsides, while during the dry season, water becomes scarce for months at a time. Ancient societies living in similar environments often relied on small cisterns or direct river access. Yet the Axumites attempted something more ambitious: large-scale water storage integrated into an urban centre. Modern hydrologists studying the region estimate that seasonal runoff across the Axum Plateau can accelerate dramatically because of the steep volcanic slopes. Without carefully designed spillways and overflow systems, reservoir walls would quickly fail under pressure, yet archaeological evidence suggests these reservoirs remained functional for centuries. The Maishum Reservoir alone measures several dozen meters across and was capable of holding thousands of cubic meters of water. That scale places it closer to the engineered hydraulic systems of Petra, Roman North Africa, and the ancient South Arabian kingdoms than to most settlements in sub-Saharan Africa during the same period. What shocks many researchers is that Axum achieved this without the extensive concrete technology used by the Romans. Instead, the builders relied heavily on stonework, earth compaction, and careful terrain manipulation. Some engineers comparing Axumite construction to later medieval reservoirs concluded that even a slight miscalculation in wall angle or soil compression would have caused catastrophic leakage or structural collapse after repeated rainy seasons. The survival of parts of these reservoirs for nearly 2 millennia strongly suggests an advanced understanding of hydraulic pressure, erosion control, and load distribution. This remains the most debated question of all. Constructing a reservoir is already difficult, but preventing one from leaking in fractured volcanic terrain is vastly more complicated. The geology around Axum consists largely of volcanic rock and dry soils, prone to cracking under pressure and temperature change. In modern engineering, terrain like this often requires synthetic liners, cement stabilization, or layered clay barriers to reduce seepage. Yet the Axumites possessed none of these technologies in their modern form, and still archaeological evidence suggests that several reservoirs retained water with surprising efficiency. Researchers studying sediment layers inside Maishum discovered unusually compacted strata along portions of the reservoir floor. Some archaeologists believe the Axumites intentionally lined sections with dense clay imported from nearby valleys, while others argue they may have mixed volcanic ash with wet soil to create a primitive waterproofing compound similar in principle to the pozzolanic reactions later used in Roman hydraulic concrete. The comparison with Roman engineering is unavoidable. Roman harbours near Portus used volcanic ash mixtures that chemically hardened underwater, allowing ports and seawalls to survive for centuries. Ethiopia also contains volcanic materials rich in minerals capable of improving water resistance when compacted correctly. However, no definitive waterproofing formula has ever been identified at Axum, leaving the exact method unknown. Another theory involves natural sediment sealing. Some hydrologists suggest the reservoirs may initially have leaked, but over decades, microscopic sediment particles carried by seasonal runoff gradually filled pores in the ground, naturally forming semi-waterproof layers. The problem with this explanation is that several reservoir walls appear intentionally engineered long before such natural sealing could realistically occur. Even more puzzling is the stability of the embankments themselves. Water pressure constantly weakens retaining walls through erosion and internal seepage. Yet portions of Axumite retaining structures still survive, despite earthquakes, seasonal flooding, and centuries of neglect. This has led some engineers to suspect the builders understood far more about permeability and drainage control than previously assumed. Certain channels around the reservoirs appear positioned specifically to redirect excess water away from structural pressure points, a principle remarkably similar to relief drainage systems used in modern dam engineering. The mystery becomes even more impressive when compared to other ancient civilizations. The Nabateans at Petra mastered desert water capture, the Maya at Tikal built limestone reservoirs in tropical climates, and the Romans engineered aqueducts stretching across continents. Yet Axum combined multiple engineering challenges simultaneously: unstable volcanic terrain, violent seasonal rainfall, high-altitude topography, and long dry periods. Some archaeologists now argue that the sophistication of Axumite hydraulic engineering has been underestimated simply because ancient African engineering historically received far less global attention than Rome or Egypt. The reservoirs themselves may only represent one visible part of a much larger hydraulic system. Archaeological surveys around Axum identified traces of channels, runoff pathways, and terraced landforms likely connected to water management, suggesting the reservoirs were integrated into broader agricultural planning rather than functioning as isolated structures. Some channels were positioned at angles that naturally reduced water velocity before runoff entered the main reservoirs. In modern fluid engineering, reducing kinetic energy is essential because uncontrolled inflow can destabilize embankments and rapidly accelerate erosion. The surprising part is how accurately the Axumites adapted their systems to the surrounding landscape. Without laser surveying tools, satellite mapping, or modern geology, they still created hydraulic structures capable of surviving powerful environmental stresses. Certain researchers compared the planning logic to the terraced hydraulic systems of Moray and the mountain water control systems of ancient Yemen. The difference is that Axum operated on a volcanic plateau where unpredictable rainfall patterns made water management even more dangerous and technically demanding. Many historians believe the reservoirs were directly connected to Axum's rise as one of the greatest powers of the ancient world. Between the 1st and 7th centuries CE, the Kingdom of Axum controlled major trade routes linking East Africa, the Red Sea, Arabia, and parts of the Mediterranean world. The empire minted coins, constructed enormous stone stelae, and maintained large urban populations, none of which would have been sustainable without stable access to water. Some historical estimates suggest Axum at its peak supported tens of thousands of inhabitants in an environment naturally vulnerable to drought. That level of urban density required reliable storage systems capable of surviving repeated seasonal cycles. In this interpretation, the reservoirs were not simply infrastructure, they were the technological foundation of imperial power itself. Without hydraulic control, Axum may never have developed into a dominant commercial kingdom capable of competing with Rome, Persia, and South Arabian states. What do you think the Axumites truly understood about water engineering nearly 2,000 years ago? Was this lost technology far more advanced than we realize, or are we still missing a crucial piece of the puzzle? Share your thoughts in the comments below. Near modern-day San Pedro de Atacama in northern Chile lies Tulor, an ancient settlement buried beneath sand for nearly 2,000 years. At first glance, Tulor looks simple, low circular walls made of mud and clay. But the deeper archaeologists investigated, the stranger the site became. Tulor was built in one of the driest environments on Earth, a desert where some regions receive less than 1 millimeter of rainfall per year. Modern scientists compare parts of the Atacama to the surface of Mars because of its extreme aridity, intense ultraviolet radiation, and violent temperature fluctuations. Yet somehow, an ancient community constructed a functioning settlement here, using materials that should have disintegrated centuries ago. The greatest mystery is not how Tulor was built, but how it survived at all. Tulor remained hidden beneath layers of desert sand until the mid-20th century, when aerial observations and local surveys revealed unusual circular formations emerging from the landscape. Systematic excavations began during the 1970s under Chilean archaeologist Lautaro Núñez and other researchers studying early desert civilizations around the Atacama Basin. Archaeologists uncovered circular adobe dwellings connected by narrow corridors, along with storage spaces, ceremonial areas, animal remains, and evidence of agriculture and irrigation. Radiocarbon dating suggested that Tulor was occupied roughly between 800 BCE and 500 CE. The settlement may once have housed several hundred inhabitants, making it one of the earliest complex communities in the region. But the excavations revealed something even more astonishing. The engineering logic of Tulor appeared far more advanced than expected for a prehistoric desert settlement. This is the central puzzle of Tulor. The Atacama Desert is considered one of the most hostile environments on the planet. In some locations, rain may not fall for decades. Daytime temperatures can exceed 35 degrees Celsius, while nighttime temperatures can drop close to freezing. Constant winds drive abrasive sand particles across the landscape like natural sand-blasting machines. Under these conditions, mud architecture should fail rapidly. Adobe structures are normally vulnerable to cracking from thermal expansion, erosion from wind, collapse from structural drying, and fragmentation caused by repeated temperature stress. Yet many Tulor walls remained identifiable after nearly 2,000 years beneath the desert. Researchers discovered that the builders were not simply stacking mud randomly. Microscopic analysis of surviving adobe fragments showed evidence of carefully mixed organic material, including straw and plant fibers combined with mineral-rich clay. This combination reduced shrinkage and helped distribute stress across the walls. Modern sustainable architecture uses similar techniques today. In fact, compressed earth construction, now promoted as an eco-friendly building technology, relies on nearly identical principles involving layered soil compression, fiber reinforcement, thermal mass stabilization, and controlled moisture distribution. What makes Tulor remarkable is that its builders may have discovered these methods entirely through empirical observation centuries before formal engineering science existed. Even more mysterious is the thickness of the walls. Some Tulor structures appear to have been built with dimensions almost perfectly suited for thermal regulation. Thick adobe walls absorb heat slowly during the day and release it gradually at night. This principle, now called thermal mass regulation, is widely used in modern desert architecture. Scientists studying passive climate systems have noted that Tulor's design resembles optimized environmental engineering rather than primitive survival housing. In other words, the settlement itself may have functioned as a giant temperature control machine. Another unexplained feature of Tulor is its unusual shape. Unlike the rectangular layouts common in many ancient settlements, Tulor is dominated by circles, circular homes, curved corridors, rounded communal spaces, and spiral-like urban organization. At first, archaeologists believed the design might simply reflect cultural preference, but later environmental studies suggested something more practical. Circular structures perform exceptionally well in desert conditions compared to square buildings. Rounded walls reduce wind resistance, minimize structural weak points, distribute stress more evenly, and decrease sand accumulation at corners. Modern aerodynamic simulations show that curved surfaces are significantly more resistant to erosive wind flow than flat surfaces. This raises an unsettling possibility. The people of Tulor may have spent generations studying how wind moved across the desert landscape and gradually adapted their architecture to survive it. That would mean Tulor was not merely a village. It may have been an early experiment in climate-adaptive engineering. Perhaps the most difficult question surrounding Tulor involves water. The Atacama Desert is so dry that NASA has used parts of it to test instruments designed for Mars missions. In some regions, microbial life struggles to survive because of the lack of moisture. Yet Tulor supported agriculture, domesticated animals, permanent settlement, pottery production, and long-term human occupation. How? Archaeologists found evidence suggesting that Tulor's inhabitants exploited underground water sources and seasonal runoff from the Andes Mountains. Small irrigation channels appear to have redirected limited water supplies with remarkable efficiency. But some researchers believe the inhabitants understood something even more sophisticated: microclimates. Subtle variations in terrain elevation, wind exposure, humidity retention, and solar heating can dramatically affect survival in desert ecosystems. Modern environmental science shows that even tiny depressions in terrain can trap cooler air and preserve moisture. Certain areas around Tulor may have created localized environmental pockets capable of supporting crops despite the surrounding desert. If true, Tulor's inhabitants possessed an advanced environmental awareness that rivaled principles used in modern ecological engineering. Ironically, the same desert environment that preserved Tulor may also have destroyed it. Over time, shifting sand dunes slowly engulfed the settlement. Excavations suggest that increasing aridity and changing wind patterns gradually overwhelmed the community's ability to maintain its infrastructure. Some climate researchers believe that even minor environmental shifts could have triggered catastrophic consequences, including reduced groundwater recharge, stronger sand transport, crop failure, and collapse of irrigation systems. This theory is particularly disturbing because modern climate science warns that many contemporary cities face similar vulnerabilities. Tulor demonstrates how fragile even highly adapted civilizations can become when environmental balance changes. The settlement may represent one of humanity's earliest examples of climate collapse. No serious archaeologist claims Tulor possessed lost futuristic technology, but many researchers argue that ancient societies are consistently underestimated. Tulor forces scientists to reconsider assumptions about prehistoric engineering. The settlement demonstrates advanced material understanding, passive thermal control, aerodynamic architectural adaptation, environmental optimization, and water conservation strategies, all developed without metal machinery, industrial science, or written engineering manuals. Comparisons have been made to adobe cities in Peru, desert settlements in ancient Egypt, North African Khazar architecture, and even modern sustainable desert housing. Yet Tulor remains uniquely mysterious because of its extreme location. Most civilizations emerge near abundant rivers, fertile plains, or predictable climates. Tulor emerged in one of the harshest environments on Earth. That alone changes how archaeologists view the capabilities of ancient human societies. What do you think about Tulor? Was this ancient settlement simply the result of generations of survival experience? Or did its builders possess environmental engineering knowledge far ahead of their time? Share your thoughts in the comments below. In the valley of Oaxaca, Mexico, stands Mitla Archaeological Site, one of the strangest architectural sites ever built in the ancient Americas. Unlike the giant pyramids of the Maya or the massive stone fortresses of the Inca, Mitla's greatest mystery is hidden in its walls. Thousands upon thousands of perfectly cut stone pieces form geometric mosaics so precise that even modern engineers struggle to explain how they were created without iron tools, industrial saws, or mechanical equipment. The most mysterious part of the complex is the Hall of the Columns, a ceremonial structure built with enormous monolithic pillars and walls covered in intricate stone patterns. Some archaeologists estimate that certain mosaic panels contain more than 100,000 individually shaped stones, each fitted together without mortar. In a region constantly shaken by earthquakes, many of these walls still stand after nearly 15 centuries. The question is unsettling. How did an ancient civilization with supposedly limited technology achieve a level of precision that resembles modern engineering? Spanish chroniclers first documented Mitla during the 16th century after the conquest of the Zapotec and Mixtec regions. Indigenous people referred to the site as a sacred place connected to death and the underworld. The name Mitla itself comes from the Nahuatl word Mictlan, meaning place of the dead. Systematic archaeological excavations began during the 19th century and intensified throughout the 20th century under Mexican archaeologists such as Alfonso Quezzo. Excavations revealed ceremonial courtyards, underground tombs, massive stone columns, and some of the most sophisticated geometric stone mosaics ever discovered in Mesoamerica. Modern laser surveys and structural studies later showed that the precision of Mitla's construction was far greater than early researchers initially believed. The walls of Mitla are unlike almost anything else in the ancient world. Instead of carving patterns directly into large stone surfaces, the builders created enormous geometric mosaics using thousands of separately cut stones assembled like an architectural puzzle. This distinction is critical. At sites such as Chichen Itza or many Maya cities, decorative reliefs were carved into finished surfaces. Mitla's builders instead manufactured countless individual pieces with astonishingly consistent dimensions and angles. Some researchers believe a single mosaic panel may contain tens of thousands of stones, each shaped to fit precisely into a larger mathematical pattern. The precision becomes even more extraordinary when examined closely. In many areas, gaps between stones are so small that inserting even a thin metal blade becomes difficult. Several stones display 90-degree cuts and repeating angular symmetry that appear almost machine-made. The mystery deepens because the Zapotec civilization supposedly relied primarily on stone hammers, sand abrasion, obsidian cutting tools, and relatively soft copper implements. None of these tools should easily produce such uniform precision on hard volcanic stone. Modern engineers studying the mosaics have compared the complexity of Mitla's patterns to advanced modular engineering systems. The repeated step fret motifs are not random decoration. Their alignment remains remarkably consistent across long sections of wall, suggesting detailed planning and mathematical organization before construction even began. Some researchers have proposed that the mosaics may also have served a structural purpose. Oaxaca lies in one of the most seismically active regions of Mexico. Earthquakes regularly damage modern buildings there even today. Yet Mitla's geometric walls survived centuries of seismic activity. Unlike Roman architecture, which relied heavily on mortar and concrete, Mitla's walls used dry-fit stone construction. The stones lock together mechanically. Several structural engineers have suggested that the repeating geometric patterns may distribute stress and vibration across the wall surface during earthquakes, functioning almost like an ancient seismic absorption system. This idea has led to comparisons with Machu Picchu and the earthquake-resistant masonry of the Inca. However, Mitla differs in one important way. The Inca used enormous polygonal blocks, while Mitla achieved stability using extremely small and mathematically repetitive components. The engineering philosophy appears completely different. Even more mysterious is the sheer labor required. If a single wall truly contains over 100,000 stones, every piece had to be quarried, shaped, transported, positioned, and fitted manually. Some estimates suggest that constructing only one ceremonial courtyard could have required millions of hours of labor, and yet the patterns remain nearly flawless. At the center of the complex stands the famous Hall of the Columns. Inside are 6 enormous monolithic stone columns carved from volcanic trachyte. Some weigh several tons each. The transportation problem alone remains unresolved. The nearest viable stone sources are believed to have been kilometers away through mountainous terrain. The Zapotec had no horses, oxen, or wheeled transport systems capable of moving such massive loads. Researchers believe human labour alone transported the columns using ropes, wooden rollers, and earthen ramps, but no definitive reconstruction has successfully demonstrated the process. The columns themselves are also unusually refined. Their surfaces display a level of symmetry and smoothness unexpected from purely hand-shaped stonework. In some sections, curvature deviations are surprisingly minimal, suggesting careful geometric control during carving. Several archaeologists have noted similarities between Mitla's columns and monolithic traditions seen at Pumapunku, where stone shaping precision also exceeds expectations for the technological period. Spanish priests recorded stories claiming that Mitla contained sacred underground chambers where Zapotec rulers and priests communicated with the gods and spirits of the dead. Beneath parts of the Hall of the Columns, archaeologists discovered tombs and narrow subterranean corridors built from carefully fitted stone blocks. Some passages remain sealed even today. Ground-penetrating radar surveys have hinted at the possibility of additional underground spaces still hidden beneath the complex. Because many areas remain inaccessible, speculation continues about the true extent of Mitla's subterranean network. Some researchers believe the underground architecture had ritual significance connected to death and rebirth. Others suggest acoustic properties may have played a role. Narrow stone corridors can amplify echoes and low-frequency sounds in unusual ways, potentially creating psychological effects during ceremonies. Like many advanced ancient civilizations, the builders of Mitla appear to have incorporated astronomy into architecture. Several doorways and alignments correspond closely with solar positions during solstices and equinoxes. Researchers studying orientation angles found that portions of the complex may have functioned as ceremonial observation points tied to agricultural calendars. The Zapotec were already known for sophisticated calendar systems, but Mitla suggests a deeper integration between mathematics, ritual, and engineering. Some scholars even argue that the repeating geometric mosaics may encode symbolic cosmological concepts rather than serving purely decorative purposes. Do you think the builders of Mitla archaeological site possessed engineering knowledge far beyond what historians currently believe? Or are we still missing a crucial piece of the ancient world's lost technology? Let us know your thoughts in the comments below. Stone walls still stand on the mountains of North Macedonia, where an entire Byzantine city vanished from history almost without explanation. Bargala was built in one of the most difficult terrains in the Balkans, far from major rivers and surrounded by rugged hills, yet archaeologists discovered advanced hydraulic engineering, massive fortifications, geometric mosaics, and urban planning sophisticated enough to rival larger Byzantine centres hundreds of kilometres away. The greatest mystery is not simply how Bargala was built, but why such an advanced city appeared in such an isolated location, and why it disappeared so suddenly. Bargala was first systematically excavated during the 20th century near the modern city of Thep. Archaeologists uncovered evidence showing that the city flourished between the 4th and 6th centuries AD, during the height of the Byzantine Empire. The settlement covered roughly several hectares and contained defensive walls, towers, basilicas, workshops, paved roads, reservoirs, and underground drainage systems. What immediately puzzled researchers was the scale of engineering compared to the estimated population. Bargala appeared far too advanced for what should have been a relatively small mountain settlement. Some historians compared its strategic importance to frontier military cities used by Rome and Byzantium to control unstable border regions. Others believed Bargala may have served as a hidden administrative centre connected to trade and military logistics across the Balkans. One of the greatest mysteries surrounding Bargala is its fortification system. The city walls were constructed using alternating layers of stone blocks and baked brick, a technique known in Byzantine engineering but rarely preserved at this scale in mountainous Balkan regions. Modern structural engineers studying the ruins notice something remarkable. The alternating materials distribute stress in ways surprisingly similar to modern anti-crack reinforcement systems. Stone provides compressive strength while brick absorbs minor movement and vibration. This may explain why parts of the walls survived more than 15 centuries, despite earthquakes, erosion, seasonal freezing, and wars. In some sections, the walls still stand several meters high. The precision of construction raises difficult questions. Many stone blocks fit tightly together, despite evidence that builders lacked advanced metal cutting equipment. Researchers comparing Bargala to other Byzantine sites noticed that some joints between stones are unusually uniform, with gaps measured in only a few millimeters. Achieving that level of consistency would have required careful planning, advanced geometry, and highly skilled labor. Similar precision is often discussed in relation to Roman engineering sites such as Pont du Gard or even Inca stonework at Machu Picchu, yet Bargala remains far less known despite displaying comparable technical sophistication. Another unresolved mystery lies beneath the city itself: water. Bargala was built in elevated terrain without direct access to a major river, yet excavations uncovered evidence of reservoirs, ceramic pipelines, drainage channels, and carefully angled water systems. Supplying water to a mountain settlement of this scale should have been extremely difficult. Archaeologists believe the city relied on springs from nearby hills, but the engineering required to transport and regulate that water remains astonishing. Some channels maintain gradients so precise that the slope changes only slightly over long distances. Modern hydraulic engineers have noted that even a small error in angle could stop water flow entirely or cause destructive pressure buildup. The situation becomes even more mysterious when climate data is considered. The Balkan interior experiences strong seasonal shifts, including freezing winters and dry summers. Ancient hydraulic systems in such environments often failed because freezing water cracked channels and reservoirs. Yet Bargala's infrastructure survived for centuries. Some researchers suspect Byzantine engineers may have understood methods of insulation, sediment control, or pressure regulation far more advanced than previously believed. Similar debates exist around Roman aqueducts and Nabatean desert water systems at Petra, but Bargala presents the same puzzle in a far harsher, mountainous environment. The central basilica of Bargala introduces another layer of mystery. Excavations revealed a large religious complex with mosaic floors, stone columns, and ceremonial architecture far exceeding what historians expected for a remote Balkan settlement. Based on population estimates, the church appears oversized. Some archaeologists argue that Bargala may have functioned as a regional pilgrimage center or an important religious headquarters connected to Byzantine political authority. Others suggest the city may have guarded valuable religious objects, imperial archives, or strategic communication routes between eastern and western territories of the empire. The mosaics themselves remain one of the most scientifically intriguing discoveries. Geometric patterns display extraordinary symmetry and mathematical organization. Mineral analysis showed that the pigments retained color stability after more than 1,500 years. In some areas, the reds, blacks, and ochres remained surprisingly vivid despite exposure to moisture and temperature fluctuation. Researchers studying the composition found evidence of carefully controlled firing temperatures and mineral mixtures. Reproducing the same durability today is not simple because small differences in heat can alter pigmentation permanently. Some geometric arrangements within the mosaics resemble advanced tessellation principles used in later mathematical studies. Historians caution against exaggeration, but the precision is undeniable. Similar mathematical symmetry appears in Roman villas and Byzantine churches across the Mediterranean, yet Bargala's remote location raises an uncomfortable question. How widespread was advanced technical knowledge inside the Byzantine world? The traditional image of isolated frontier settlements may be deeply inaccurate. Perhaps the most disturbing mystery surrounding Bargala is its disappearance. Historical records suggest instability swept across the Balkans during the 6th and 7th centuries as Slavic and Avar groups expanded into Byzantine territory. However, the archaeological evidence at Bargala does not fully match the idea of total violent destruction. Some structures collapse gradually rather than through fire or siege. In several areas, valuable objects appear to have been deliberately removed before abandonment. This suggests at least part of the population had time to evacuate. That detail changes everything. If Bargala's residents escaped in advance, what exactly forced them to leave permanently? Disease outbreaks, climate shifts, military collapse, economic failure, or political withdrawal are all possibilities. Yet none fully explain why such an advanced strategic settlement was never rebuilt. Byzantine cities of military importance were often restored after invasion. Bargala was not. Another mystery involves its location. The city stood along routes connecting different parts of the Balkans, giving it visibility over mountain movement and trade corridors. Some historians compare Bargala to a surveillance or control outpost rather than a normal urban centre. Its elevated position allowed defenders to monitor movement across large distances. In military terms, the site was ideal for early warning and regional coordination. But constructing a technically advanced city in difficult terrain would have required enormous resources. Why invest so heavily in this isolated region unless something strategically critical existed there? Modern archaeological surveys continue revealing hidden structures beneath the soil around Bargala, suggesting the settlement may have been larger than originally believed. Ground-penetrating radar has identified buried walls and additional architectural features outside the known defensive perimeter. Every new discovery complicates the picture further. Instead of a small, forgotten Byzantine town, Bargala increasingly appears to have been a sophisticated engineered centre whose true role was lost after the collapse of imperial authority in the Balkans. What do you think really happened to Bargala? Was it simply abandoned after invasion, or did an advanced piece of Byzantine history disappear before the world could fully understand it? Share your thoughts in the comments below. High above the rugged hills of northeastern North Macedonia stands Kokino, a Bronze Age site that should not exist in the form archaeologists found it. Carved directly into volcanic rock nearly 1,000 meters above sea level, Kokino appears at first glance to be nothing more than a windswept hill of fractured stone. But when the sun rises during the summer and winter solstices, narrow stone markers align with extraordinary precision, revealing a pattern many researchers believe was intentionally engineered more than 3,800 years ago. What makes Kokino truly mysterious is not simply its age, but the possibility that an isolated Bronze Age society possessed astronomical knowledge far beyond what historians once thought possible. The site first gained major international attention in the early 2000s, when archaeologists studying the volcanic outcrop noticed unusual stone cuts and observation points embedded into the terrain. Further analysis suggested that several of these markers aligned with the sunrise during key solar events, including the equinoxes and solstices. Some researchers compared the site to Stonehenge, while others argued that Kokino might represent an entirely different form of ancient observatory, one integrated directly into a natural volcanic formation rather than constructed from transported megaliths. The first major mystery surrounding Kokino is its improbable location. Most Bronze Age settlements were built near rivers, fertile valleys, or trade routes. Kokino was built on a harsh volcanic ridge exposed to powerful winds and dramatic seasonal temperature changes. The terrain is uneven, difficult to access, and unsuitable for large-scale agriculture. Yet ancient people repeatedly climbed this mountain and modified its surface with deliberate precision. Archaeologists have identified carved seats, narrow observation corridors, and stone notches cut into basalt formations. The question remains deeply unsettling. Why would a Bronze Age society invest enormous effort into transforming an inhospitable mountaintop into what appears to be a celestial observation centre? One possible answer lies in survival itself. Ancient civilizations depended on accurate seasonal prediction. A mistake in planting cycles could mean famine. At Kokino, the sunrise aligns with specific stone markers during the summer solstice, winter solstice, and equinox periods. This would have allowed observers to track the changing seasons with surprising accuracy. Modern measurements suggest some alignments deviate by only a few degrees. That level of precision becomes even more mysterious, considering the technological limitations of the period. The people of Kokino had no telescopes, no optical lenses, and no advanced mathematical notation. Their measurements would have depended entirely on naked eye observation repeated across generations. The second major mystery is even more controversial. Several researchers believe Kokino may contain evidence of lunar tracking, not just solar observation. Certain stone markers appear to correspond with the 19-year metonic cycle of the moon, a complex astronomical pattern formally documented centuries later in ancient Greece. The metonic cycle occurs because 19 solar years closely match 235 lunar months, allowing ancient astronomers to synchronize lunar and solar calendars. If Kokino's builders truly understood this cycle, it would imply a level of astronomical continuity requiring decades of careful observation. Critics argue that these alignments may simply be coincidence. Volcanic rock naturally fractures into irregular shapes, and humans are often inclined to see patterns where none exist. However, supporters of the astronomical interpretation counter that the number of meaningful alignments at Kokino exceeds what random geology would reasonably produce. Some observation points only function correctly when viewed from very specific carved positions, strongly suggesting intentional design rather than accidental formation. Another unresolved puzzle involves engineering. Unlike Stonehenge, Kokino did not require transporting massive stones across great distances. Instead, its creators modified existing volcanic basalt. But basalt is an extremely hard material. Even modern cutting tools struggle against dense volcanic rock. Bronze Age tools would have been primitive by comparison, consisting mainly of early metal implements and stone hammers. Yet several cuts at Kokino appear surprisingly clean and purposeful. Some researchers propose that ancient workers may have used repeated heating and cooling techniques to fracture the rock in controlled ways. Others believe the marks are partly natural but selectively enhanced by humans. No consensus exists. The site also raises questions about social structure. Archaeologists have found relatively limited evidence of a large permanent settlement surrounding Kokino. This suggests the site may not have functioned as a normal city. Instead, it could have been a ceremonial centre visited only during the important astronomical events. If that theory is correct, then the individuals capable of interpreting the sky may have held extraordinary authority. In many ancient cultures, astronomy and religion were inseparable. Predicting eclipses, solstices, or seasonal transitions could easily appear supernatural to ordinary people. At Kokino, knowledge itself may have become a form of power. Some researchers believe the carved stone thrones found at the site strengthen this idea. These elevated seats overlook the horizon and align with certain celestial positions. One theory suggests elite observers or ritual leaders sat there during ceremonies connected to the sun. Similar symbolic observation platforms have appeared in several ancient cultures where rulers linked themselves to cosmic cycles in order to legitimize authority. The Maya, Egyptians, and Mesopotamian priesthoods all connected celestial events with divine order. Kokino may represent a smaller but equally sophisticated version of the same phenomenon. The comparisons become even stranger when Kokino is examined alongside distant ancient observatories. Chanquillo in Peru, built more than 2,000 years ago, contains 13 towers aligned with solar movement across the horizon. Nabta Playa in the Sahara Desert includes stone circles linked to seasonal astronomy dating back thousands of years before the pyramids. None of these civilizations had known direct contact, yet each developed sophisticated methods of tracking celestial motion. This recurring pattern has forced archaeologists to reconsider a long-standing assumption that ancient societies only developed advanced astronomical systems after urban civilization became fully established. Perhaps the most haunting mystery of Kokino is how much knowledge may have disappeared forever. No written records explaining the site have ever been discovered. No astronomical charts survive. No inscriptions explain who built the observatory, how observations were conducted, or why certain celestial events mattered so deeply to its creators. Everything modern researchers know comes from stone alignments, excavation layers, and mathematical reconstruction. Humanity is effectively attempting to decode the shattered remains of a scientific system abandoned nearly 4 millennia ago. What do you think Kokino really was? A sacred ritual site? Or an ancient observatory far ahead of its time? Share your thoughts in the comments below. Near the western shores of Lake Turkana, in one of the harshest landscapes in East Africa, archaeologists uncovered something that should not have existed there at all. The site now known as Namoratunga appeared at first to be little more than a cluster of dark volcanic stones rising from the dry ground. But as excavations began during the 1970s, researchers realized the stones were not random. They had been deliberately erected into a complex arrangement unlike anything previously discovered in sub-Saharan Africa. The first surveys identified approximately 19 basalt pillars standing upright around burial cairns and stone platforms. Early radiocarbon dating from charcoal and associated organic remains suggested the site was constructed between roughly 300 BCE and 300 CE. That immediately created a historical problem. At the time, many scholars believed societies around Lake Turkana were relatively small pastoral communities without large-scale engineering capabilities, yet each excavation season revealed something new. Archaeologists uncovered carefully arranged burials, ornamental beads, fragments of ceramics, and evidence of long-distance trade. Some glass beads were chemically linked to trade routes stretching toward the Nile Valley and the Indian Ocean coast. The implication was staggering. Communities living around Turkana may have been connected to regional exchange networks thousands of kilometers wide. During excavations in the 1980s, researchers Mark Lynch and L.H. Robbins noticed another anomaly. Several of the pillars appeared to align with the rising positions of important stars used in Cushitic calendrical systems. Suddenly, Namoratunga transformed from an isolated burial site into a possible prehistoric observatory. That theory would ignite one of the most controversial debates in African archaeology. The first mystery surrounding Namoratunga is brutally simple. How was it built at all? The Turkana Basin is one of the hottest and driest regions in Africa. Modern temperatures frequently exceed 40 degrees Celsius. Water is scarce, vegetation is limited. Even today, transporting heavy materials across the volcanic terrain is difficult without vehicles. Yet the builders of Namoratunga somehow quarried, transported, positioned and stabilized nearly 20 basalt pillars, weighing hundreds of kilograms each. Basalt is not an easy stone to manipulate. It is dense, extremely hard and fractures unpredictably. Unlike softer limestone used in many Egyptian monuments, basalt requires enormous effort to shape or extract using primitive tools. Some researchers estimate that several pillars may have been transported from distances exceeding several kilometers. Without wheels, cranes, or pack animals on an industrial scale, the logistical challenge becomes extraordinary. Even Stonehenge, often compared to Namoratunga, required immense communal coordination to move stones across southern Britain. But Stonehenge existed within a far wetter environment with greater timber availability and agricultural infrastructure. Namoratunga was constructed in near-desert conditions. The mystery deepens when examining the stability of the pillars themselves. The ground around Lake Turkana experiences significant thermal expansion because of dramatic temperature fluctuations between day and night. Modern concrete structures in similar environments often crack after repeated heat stress cycles, yet many of Namoratunga's basalt pillars remain standing for nearly 2,000 years. Geologists studying the stones propose that the builders may have intentionally selected basalt with unusually high density and thermal resistance. Some pillars also appear to have been partially buried below the surface to increase stability, a surprisingly advanced structural solution for what was once assumed to be a technologically simple culture. No one knows how these engineering decisions were discovered. The greatest mystery of Namoratunga revolves around the sky. In 1980, Lynch and Robbins published research suggesting that at least 7 of the basalt pillars aligned with the rising positions of stars associated with an ancient Cushitic lunar calendar. These included Sirius, Aldebaran, Bellatrix, the Pleiades cluster, and Triangulum. If accurate, the implications are enormous. The Cushitic calendar system used calendar, complex stellar observations to track seasonal cycles. In arid East Africa, predicting seasonal change could mean survival. The arrival of rains determined migration routes, grazing patterns, and food availability. A society capable of mapping recurring stellar positions with physical monuments would possess an extraordinary practical advantage. What shocked researchers was not merely the possibility of astronomical observation, but the apparent precision. Some alignments showed deviations of only a few degrees from calculated stellar rising positions for the proposed time period. Critics argued this could be statistical coincidence. However, supporters countered that the probability of multiple pillars accidentally corresponding to major calendrical stars was unusually low. The debate remains unresolved because Namoratunga lacks written records. Unlike ancient Egypt or Mesopotamia, there are no inscriptions explaining the purpose of the site. Everything must be reconstructed from geometry, orientation, and archaeology alone. Still, the parallels with other ancient observatories are difficult to ignore. Stonehenge tracks solar movement through monumental stone alignments. Nabta Playa contains prehistoric stone circles linked to astronomical observation. Chankillo functioned as a solar calendar with 13 observation towers. These civilizations were separated by oceans and developed independently, yet all arrived at a remarkably similar concept: transforming the movement of the heavens into permanent architecture. That convergence raises a disturbing possibility. Perhaps ancient societies around the world understood observational astronomy far earlier and far more accurately than modern historians once believed. Some anthropologists even argue that astronomy may have been among humanity's first true sciences. Long before writing, metallurgy, or states, people may have been systematically studying celestial cycles because survival depended on it. If that is true, then Namoratunga may preserve evidence of a forgotten scientific tradition emerging from the deserts of East Africa. Excavations beneath the stone complex revealed another layer of mystery. Archaeologists discovered burial chambers containing human remains alongside beads, ornaments, and ceremonial objects. The arrangement suggested the site held deep ritual significance. Some burials appeared carefully positioned relative to the standing stones, implying the astronomical alignments and funerary practices may have been connected. This mirrors patterns seen in numerous ancient civilizations where celestial observation became intertwined with religion and death. In Egypt, tombs aligned with stars associated with the afterlife. In Mesoamerica, pyramids reflected solar cycles tied to divine kingship. Even at Stonehenge, cremated remains were buried near astronomical alignments. Namoratunga may represent an African expression of the same phenomenon, the merging of cosmology, timekeeping, and ritual burial into a single sacred landscape. But another anomaly complicated the picture. Chemical analysis of some artifacts suggested external influence or long-distance exchange. Certain beads resembled materials linked to broader East African trade systems. That means the people of Turkana were likely not isolated nomads, but participants in a network of communication extending across enormous distances. If knowledge travelled with trade, then astronomical ideas may have spread as well. This possibility radically changes older assumptions about technological development in ancient sub-Saharan Africa. What do you think Namoratunga truly was? A sacred burial ground or an ancient observatory built by a civilization far more advanced than we realize? Let us know your thoughts in the comments below. In northeastern Thailand, deep within the plains of Kalasin province, lies Muang Fa Daet, an ancient city surrounded by enormous earth walls and water moats that still remain visible after more than 1,000 years. But the greatest mystery of Muang Fa Daet is not simply its age. It is the unsettling possibility that an inland Southeast Asian civilization once possessed urban planning, hydraulic engineering, and material technology far more advanced than historians once believed. Even today, archaeologists still cannot fully explain how some of its brick structures survived centuries of tropical rain, heat, flooding, and erosion, while many younger buildings across the region completely disappeared. The site was first systematically documented during archaeological surveys in the 20th century, although local villagers had known about the ruins for generations. Excavations later revealed a massive Dvaravati-era settlement covering more than 140 hectares. Archaeologists uncovered Buddhist stone carvings, ancient brick foundations, pottery fragments, religious monuments, and a complex network of moats surrounding the city. What immediately puzzled researchers was the scale of organization required to construct such a settlement in a region not traditionally associated with large urban engineering during that period. From above, Muang Fa Daet appears almost unnaturally geometric. The city is enclosed by oval-shaped embankments and multiple concentric moats, with curves so consistent that some researchers questioned whether the builders possessed sophisticated surveying techniques. Unlike many ancient settlements that expanded chaotically over time, Muang Fa Daet appears deliberately planned. Certain gates and pathways align with cardinal directions and possibly seasonal solar positions, suggesting the city may have combined political, religious, and astronomical functions into a single integrated design. This raises a disturbing historical question. How did an inland civilization in ancient Southeast Asia achieve urban planning precision comparable in some ways to far larger and better-known civilizations? While Muang Fa Daet was not as massive as Angkor in Cambodia or Mohenjo-Daro in the Indus Valley, the underlying principles of controlled geometry and water management show surprising similarities. Yet unlike those civilizations, very few written records survived to explain how the city functioned. One of the greatest engineering mysteries lies in the moat system itself. Northeastern Thailand experiences intense seasonal extremes. During monsoon periods, enormous volumes of rainwater can flood lowlands, while dry seasons can bring severe water shortages. Despite these harsh conditions, Muang Fa Daet appears to have maintained long-term urban stability for centuries. Geological surveys indicate the moats were not merely defensive structures. They likely acted as reservoirs, drainage channels, flood regulators, and possibly even environmental cooling systems. Modern hydrological studies suggest the builders may have used extremely subtle elevation gradients to control water flow naturally across the city. In some sections, the difference in height between channels measures only a few centimeters across long distances, Achieving such precision without modern instruments would have required remarkable observational skill. Similar water management sophistication can be seen at Angkor's berets in Cambodia, yet Muang Fa Daet predates some of the Khmer Empire's most famous hydraulic systems. Another mystery emerges from the city's stone carvings. Excavations uncovered numerous sandstone steles depicting scenes from Buddhist Jataka tales. The carvings contain remarkably smooth curves, consistent line depths, and intricate details that appear unusually refined for the period. Some archaeologists argue that ordinary iron tools alone would have struggled to produce such uniform precision on sandstone surfaces. The debate becomes even more fascinating when metallurgical evidence is considered. Several Dvaravati sites across Thailand have revealed evidence of advanced ironworking and bronze casting. If Muang Fa Daet artisans possessed higher quality metal tools than previously assumed, it could explain the extraordinary precision found in the carvings. Yet direct evidence remains incomplete, leaving researchers caught between possibility and uncertainty. But perhaps the most baffling mystery of Muang Fa Daet is its brick technology. Across much of tropical Southeast Asia, humidity destroys ancient structures with brutal efficiency. Rainwater penetrates porous surfaces. Plant roots crack foundations apart. Extreme temperature cycles weaken masonry over time. In many areas, even buildings only a few centuries old suffer catastrophic deterioration. Yet parts of Muang Fa Daet's brick foundations and structures have survived for over 1,000 years. Scientists analysing surviving bricks discovered something unusual about their composition. The clay appears to contain highly balanced mineral distributions, including silica and iron compounds that may have improved durability during firing. Microscopic analysis also suggests relatively uniform firing temperatures, indicating the builders maintained controlled kiln conditions rather than simple open-fire baking methods. This is extremely significant because consistent firing temperatures are difficult to achieve without deep practical understanding of combustion control, airflow regulation, and material behavior. Experimental archaeologists attempting to reproduce ancient Southeast Asian bricks found that small variations in temperature could dramatically weaken final strength. Yet many Muang Fa Daet bricks demonstrate surprising density and resistance to erosion. Some researchers compare this durability to Roman bricks and ancient Indian-fired clay technologies. Roman builders famously used carefully engineered mixtures containing volcanic ash to improve longevity, while ancient Indian urban centers, such as those of the Indus Valley, produced standardized fired bricks thousands of years earlier. Muang Fa Daet appears to represent another independently sophisticated brick tradition, yet far less is understood about how its builders mastered the process. Another unexplained factor involves the city's environmental adaptation. Many surviving structures were positioned on slightly elevated terrain relative to surrounding flood zones. This may indicate advanced understanding of seasonal hydrology and soil stability. In some areas, archaeologists found evidence that builders layered compacted earth beneath foundations before placing brick structures above. Such techniques could have reduced long-term sinking and water damage. The city also reveals evidence of vast labor coordination. Constructing multiple moats, transporting earth, firing thousands of bricks, carving stone monuments, and maintaining urban infrastructure would have required organized administration and specialized workers. Yet historians possess very limited written evidence describing the political structure behind these achievements. This absence of records creates one of the most haunting aspects of Muang Fa Daet. A civilization clearly capable of large-scale engineering somehow faded almost silently from history. Unlike Egypt, Rome, or Imperial China, the Dvaravati world left relatively few texts behind. Much of its knowledge may have vanished through climate change, warfare, political collapse, or simple historical neglect. What do you think Muang Fa Daet truly was? Simply an ancient city or evidence of a forgotten level of knowledge lost from Southeast Asian history? Share your thoughts in the comments below. Bilsk Hill Fort lies across the forest steppe region of central Ukraine, near the Vorskla River, covering an area so vast that early researchers struggle to believe it was built during the Iron Age. The site first attracted scholarly attention in the 19th century, but large-scale archaeological investigations accelerated during the 20th century, when aerial surveys revealed enormous earthworks stretching across the landscape. What archaeologists initially believed were disconnected embankments turned out to be part of a massive fortified complex covering nearly 5,000 hectares. The outer defensive perimeter alone extends for more than 30 kilometers, making Bilsk one of the largest ancient fortified settlements ever discovered in Europe. Excavations conducted during different decades revealed increasingly disturbing contradictions to accepted history. Early digs uncovered Scythian ceramics, iron weapons, bronze ornaments, and traces of large wooden structures. Later excavations exposed workshops, storage pits, ritual areas, and evidence of organized urban planning. In the 1970s and 80s, archaeologists began finding imported Greek amphorae and luxury goods originating from colonies along the Black Sea coast. By the early 21st century, LiDAR surveys and satellite imaging revealed that much of the site still remained buried beneath forests and agricultural land. Every new excavation seemed to expand the mystery instead of solving it. Some researchers believe Bilsk may be the lost city of Gelanus, described by the Greek historian Herodotus in the 5th century BCE. According to his writings, Gelanus was an enormous wooden city inhabited by a mixture of Greeks and Scythians, surrounded by gigantic walls and filled with temples dedicated to Greek gods. For centuries, historians dismissed the description as exaggeration. But Bilsk changed that argument forever. The first mystery surrounding Bilsk is its sheer size. Even compared to famous Iron Age settlements in Europe, the site appears disproportionate to its era. The fortified oppidum of Heuneberg covered roughly 100 hectares. Major Celtic hill forts across Western Europe rarely exceeded several hundred hectares. Bilsk, by contrast, extends across nearly 50 square kilometers. To construct defensive walls on this scale required the movement of millions of cubic meters of earth. Some embankments rise more than 10 meters above the surrounding terrain, when measured from the base of the defensive ditch. Archaeologists estimate that tens of thousands of workers would have been required to complete the fortifications within a realistic time frame. Yet mainstream history traditionally describes the Scythians as largely nomadic horse cultures with limited permanent urban infrastructure. That contradiction has never been fully resolved. The engineering itself creates even deeper questions. The walls were not random piles of soil. Excavations show layered construction methods designed to stabilize the embankments against erosion. Certain sections appear reinforced with timber frameworks, similar to techniques later seen in medieval fortifications. Defensive ditches were strategically placed to maximize visibility and create kill zones against attackers approaching from open steppe terrain. Some archaeologists argue that Bilsk functioned as a seasonal refuge rather than a permanent city. But this theory struggles to explain the enormous labor investment, the extensive internal zoning, and the evidence of long-term occupation. Others propose that Bilsk was the center of a regional political confederation capable of mobilizing massive labor forces across the steppe. If true, this would suggest a level of political organization among the Scythians far beyond traditional assumptions. One of the strangest aspects of Bilsk is that much of its architecture was made from wood, a material that normally disappears almost completely over time. Yet traces of large wooden structures continue to emerge beneath the soil. Herodotus described Gelanus as a city built almost entirely from timber, including temples and defensive towers. For centuries, historians doubted that a wooden city could survive long enough or grow large enough to rival stone-built Mediterranean centres. But excavations at Bilsk have uncovered post holes, burned timber remains, and construction patterns suggesting organised wooden architecture on an enormous scale. The problem is logistical. Maintaining a settlement of this size would have required extraordinary quantities of wood. Researchers estimate that large-scale deforestation must have occurred around the region during Bilsk's peak occupation between the 7th and 4th centuries BCE. Timber would have been needed not only for homes, but also for defensive walls, workshops, roads, gates, towers, and heating systems during brutal Eastern European winters. This raises another unanswered question. Where did the labour and resources come from? The surrounding environment could not easily sustain a gigantic urban population without advanced agricultural systems. Yet evidence suggests Bilsk supported thousands, possibly tens of thousands of inhabitants. Storage pits discovered across the settlement indicate large-scale grain collection and redistribution. Some pits contain traces of millet, barley and wheat, implying organised agricultural production rather than simple subsistence farming. In many ways, Bilsk resembles the logistical complexity of later urban civilizations more than the mobile tribal societies usually associated with the Scythian world. Another major mystery emerged when archaeologists began uncovering imported Greek goods throughout the settlement. Excavations revealed amphora fragments from Black Sea colonies, fine ceramics, jewellery, wine containers, and luxury items originating hundreds of kilometres away. This discovery shocked researchers because Bilsk lies deep inland, far from the Mediterranean world. The quantity of imported goods suggests regular trade rather than isolated exchange. Some scholars now believe Bilsk may have controlled a major trade corridor linking the Black Sea to the interior of Eurasia. If so, the city may have served as a gateway between Greek colonies and steppe populations extending towards Central Asia. The economic implications are enormous. Trade networks on this scale required security, administration, storage systems, and diplomatic coordination. In effect, Bilsk may have operated as a commercial hub comparable in regional importance to certain early urban centres in the ancient Near East. Some comparisons have even been made to the role played by Carthage in controlling Mediterranean exchange routes, although on a smaller scale. Yet there is still no consensus about who controlled the city. Was Bilsk ruled by the Scythian elites, a mixed Greek-Scythian population, merchants, clans, a military aristocracy? The archaeological record provides clues, but no definitive answer. Perhaps the most unsettling mystery involves the massive burn layers discovered across several parts of the settlement. Archaeologists identified evidence of intense fires that destroyed large sections of Bilsk during different occupation phases. Charred timber remains and ash deposits indicate catastrophic events rather than isolated accidents. Some areas show signs of rapid destruction, while others suggest gradual abandonment. The cause remains unknown. One theory suggests military invasion. Another proposes internal conflict between rival Scythian factions. Climate instability may also have contributed. Around the 4th century BCE, environmental changes across the Eurasian steppe may have disrupted trade routes and agricultural production, but none of these explanations fully account for the scale of decline. What makes the mystery even stranger is that Bilsk did not simply vanish overnight. Certain areas continued to be occupied after major destruction events, while others were abandoned permanently. It is almost as if the settlement fragmented over time instead of collapsing in a single catastrophe. This pattern resembles the slow disintegration seen in other ancient centres such as Cahokia or parts of the late Bronze Age Mediterranean world, where environmental stress, economic instability, and political fragmentation combined into long-term decline. Bilsk forces historians into an uncomfortable position. For generations, the Scythians were portrayed primarily as mounted nomads, highly mobile warrior societies without major urban traditions. Yet Bilsk contradicts that image almost completely. The site demonstrates advanced engineering, organized labor, economic specialization, regional trade integration, and large-scale defensive planning. Some scholars now argue that the Scythian world was far more diverse than previously believed, containing both nomadic and semi-urban populations operating within interconnected political systems. Others believe Bilsk represents a unique anomaly rather than a broader pattern. But the unanswered questions continue growing. Why build fortifications large enough to defend an entire city-state in a region supposedly dominated by mobile tribes? Why invest enormous resources into permanent infrastructure if the population remained largely nomadic? Why do historical records barely mention a settlement of this scale outside the writings of Herodotus? And perhaps most disturbing of all, how many other massive ancient centres remain hidden beneath the forests and plains of Eastern Europe, still undiscovered because historians never expected them to exist there in the first place?